Okay, I guess we're live, maybe? I guess I really should get headsets to check the audio. Um, so yeah, I'm going to be messing around with some compilers and crap, but before I start, let's kick off compiling DOS from OS2. Just because I want to see how painful this is. This is an 86 box. This is what, 6.123 if I remember correctly. So if I remember correctly, I can run OS2, and I can go and make clean, and then this should go to all the directories and clean out everything. So in this case, what I've done is I've modified the build process for DOS 4 to run under OS2. Let me move that pointer so it stops blinking like crazy. Just because this would have been the best way to do this. Or at least back in the day. And I know someone was saying that this didn't exist in '88, but you know, it kind of did, because you know, Windows 386 was a thing in 1987. You know, and they did have the football and pigskin for OS2 that actually does have v86 mode. So you know, deep inside of Microsoft, you know, I believe they had the technology to really pull this off. Plus, you know, there is OS2 versions of the compilers and stuff. So I can't imagine them not wanting to use OS2 to build DOS. Not to mention the cool feature here is that, or at least the release versions of OS2 version 2 can actually boot DOS from diskette. So you can build and test OS2 on the same computer. You know, before there was VMware or whatever, the hypervisor-like thing for OS2. So yeah, kind of cool. All right, so this is almost done cleaning up, I think. Because now we're in the drivers, and then it'll be the memory thing, and then the stupid select program. Oh, sorry, now we're doing the EMM 386. All right, there we go. So now we can just type in nmake, and it should just take care of itself. It'll occasionally shell out to DOS. Ah, well, that ended well. So last time it crashed on me, it crashed the shell. So that did not happen. So that was messages, clean. Okay. Wow. It really did not like that. Huh. Well, I guess that's what you get for using super super beta version of OS2. Huh. Oh, well, let's go back to what I was really going to work on was VMware. Okay, so what I wanted to play with was old GCC. So some stuff I think I already unpacked. What we really need is a C compiler to first build our GCC. So let me just clean this stuff out because none of this stuff matters. Let's just clean this out. We don't need this. Okay, so we've removed a lot of stuff. Now if we go to our downloads, so basically it's going to use that, but I don't want the whole thing. So let me start a notepad. I think I want to use this GCC for NT thing because I think I patched the linker, because by default the linker generates massive executables. So let's test this out. Okay, so that's extracted. So let me just write this down. So I'm using GCC for MT. So 132S, no. Where are we? Must be C. So let's check our environment. So C drive, so that's fine. I think it's like 1.0. Or no, it's the 32-bit, so it's version 8. Okay. So just a quick hello world thing. And our height is 17 kilobytes, which is pretty bloated, but you know, it works. So that's all that matters. Alright, so the first thing we need is our assembler. Now I know I got this from GitHub, so I probably should get the links for this stuff. Let's see, GitHub, search for gas. So this is the gas I'm using. And then on archive.org, believe this is where I had that Xenix MT. Hype, yeah. Oh, your mic is way low. Okay, sorry. Is this better now? I hope. Yeah, sorry, I wasn't expecting anyone in chat. Sorry. Let's see where volume is. I mean, it shows it popping. Much better. Okay, cool. Yep, better. All right. Awesome, awesome. All right, where was it? All right, Xenix. So I wanted... Where are you? Not this, not this. I think it's this one. Yeah, I get my files all mixed up and lost. No, this isn't it. It's close to it, but it's not the one I'm looking for. Maybe it's not under this. I think it was like... So I'm looking for this old version. Oh, no, that's not it. Like GCC for MT. Because I can't remember where I put the linker. It's just part of the problem. There we go. This is it. This is it. I can never remember this stuff. So that's why I try to write it down. So we got Visual C from here. All right, so first thing we need to do is unpack the assembler. So users downloads unzip -a users, because I'd already downloaded this. I don't have unzip, really? Okay, fine, be that way. I know I put it somewhere. Because the other thing too, this is like the problems with everyone doing the MS-DOS thing. Once things get stored on GitHub, it mutilates all the text. So -a is the hidden weapon here. So if you run unzip just by itself, A here, auto-convert to text files. So this is why everyone screwed up when trying to build DOS 4. Because they've obviously never dealt with this before, but you'll see as it unpacked here, it's putting text next to all these files. So that's why I was able to build it, and a lot of other people failed right off the bat. Because DOS handles text files differently than Unix. So I'm just going to rename this because I don't like the main thing. So if I run like Notepad on just some random file, it looks normal. And if I type it out, yeah, it looks normal too. But if I didn't unzip it correctly, let me see. Because then again, I'm on Windows 10. Windows 10 will make it look like it's okay because they updated the notepads and stuff. But it looks normal, but it's not. Yeah, I think this one interprets it. Yeah, it interprets it. So it's hiding it. The newer versions will filter the stuff so that way, as a user, you don't see it. Do I have WSL in here? Don't think I do. No, I don't. It's a lot of work just to go show a text file. I'm trying to think. I mean, it almost doesn't matter. But trust me, the -A, it matters a lot. M4. I wish I had M4. No M4 here. So I should make a note of that. Unzip with the -A. Unzip -A and explain what the fuck is the ASCII deal with CR LF versus LF. Maybe I had a hex editor. I don't know, but I didn't log on to this machine because I usually like starting with a machine that has nothing on it, just so I don't have to rely on everything I have normally installed. Because then it feels like the M4 thing, like, oh, of course I've got this, but to you, as a normal person, now you have nothing. Yeah, show the file. Yeah, happy hacking. Thank you. Nick, yes. Let's see, hex editor. I like this one. Let's see, install. 14 megabytes for a hex editor, but it's modern software, so what do you expect? I guess there's no open. There we go. So hex editor neo. All right. Your free copy. Okay, that's fine. So no, I don't want to update. I just want to open files. So go into here. So this one I unzipped without anything. So we just grab a file. Oh, this is like terrible. Because I know what I'm looking for. It's the 0As. This is, let's see if we can find a small file just so you can put them side by side. So let's see, config.h, that's probably better. Open config.h. Okay. And then let's go ahead and open the other one. And we want config.h right here. Okay, so we can tab between the two of them. And if you see as I quickly move between them, they are different. So when I define Xenix here, this is the Unix one, and you'll see it embeds 0A, or number 10, as the control character for the next line. So that works great in Unix and stuff, but on MS-DOS and old Windows source code, it does not. So you'll see it's character return line feed instead. So you get the 0D, 0A. So if you don't have this in, all those older programs and stuff will absolutely fail. A lot of the Microsoft compilers and stuff were updated in the later 80s to like compensate with this, and they'll read the files, but if it's a data file, like the text that it uses to parse all the messages for DOS for, it is not going to work because it expects character return line feeds. Yeah, I probably should. If I have WSL like kind of on here, let me see if I can just grab a distro. Whatever passes for Ubuntu or whatever the heck it's called. Long-term support. Yeah, why not? I really don't care. So we got generic or 24. Yeah, let's get it. Personally, I like the Windows subsystem for Linux just because you have the best of both worlds then. So, anyways, yeah, so that's the text file reason. Isn't that hours of endless fun? Do I have this one running? Nope. So, over here, my prompt. So now I can run nmake-f makefile. I just know this is here because I'd already patched this one yesterday. There we go. So this gives us a special version of GAS, the GNU assembler. But what's special about this one is that it creates object files for Xenix, the Microsoft Unix. But on the Microsoft Unix, it only uses Microsoft tools. So accidentally, this creates files that the Microsoft linker and stuff can use. And I found this one out by accident. But as well as DOS to Unix, Unix to DOS command. Yeah, there is that too. But I find unzip easier just because it does everything all at once. And it can auto-detect pretty well. Yeah. It's like one of those personal preference things. There's a million ways to do it. I've seen bash scripts, M4 scripts, various utilities, but I've always found zip and unzip to be super fast. So we don't need this one. So we can copy out the executable. And then the next thing we want to do is unzip -a. Just get all the GCCs. Now these I've updated on GitHub. So I've kind of cheated on that. Let's see. Go back out of here. Yeah, I guess if you've ever seen my stupid GitHub page. There we go. And from the last commits, I'd updated the make file so it actually makes from Microsoft C. Oh yeah, and I forgot to delete files because I was trying to convert the make files from the Unix thing because heaven forbid anything like make works standardly. And then I don't know why, but I actually wrote this because I have no life, I guess. Let's see. Oh, we do need bison. We do need bison. Alright, so let's see, explain what the heck the deal is that. So we need bison. I think it's also in the GCC for NT, if I'm not going to, or I guess I am going to try to like create the world. So if we go back here, yeah, there we go, bison, nice. So I can copy it from here. I guess this is like putting together like all the stuff I'd done over the years. This is not quite the first time I've tried to do this. Alright. I guess I just used a build script on this. So, bison build? Nope, that's not mine. Ah, I modified the make file. Okay, that works. That works. Yeah, I've seen people use binary set as well. It can get a little hairy, pardon the fun. So let's replace this with this, and then as.exe, which we're going to copy that from, I guess just dot dot. Oh, okay, yeah, like that. Okay, so if we've done this right, and I could probably just zip this up into one file and just shove it on archive if anyone cares. But if I've done this right, I should just be able to type this and it should compile the compiler, the libraries, and the test program all in one shot. So here's nothing. And no. Oh, because it's hard-coded for Bison.simple. Where the heck is it trying to go? At prefix, sure. Yeah. That's what you get for standing on your own shoulders from years ago. Prefix. Where's prefix? Prefix is at prefix. Well, that was very smart. So I'm going to change data dir to dot slash. I think that would be better. So let's save that, update my notes. So let's see, and make, what if it's got a clean, oh. Alright, let's recompile. Okay. Oops. So clean from here, and try it again. Alright, so we fixed Bison so it sits in the local directory. Ah, there we go, it compiled the whole thing. Oh, it's so amazing how fast modern machines are. So, hello from GCC 1.25. So if we break that down, we go xgcc-b hello.c-o hello.o bj, and we can see that it runs the C preprocessor. It's trying to include a directory that doesn't exist, so it can't find standard I/O, but it doesn't matter for now. And this builds the 125C compiler. Then it uses the assembler to give us an object file. And then, of course, there's no linker. There's no GNU linker. I guess it didn't call it OBJ I wanted. Oh, because I should just done C. My mistake. There we go. So now we got the object. And then should almost just write this down because it's a little weird to do the linking. But this part right here, you have to basically manually link the executable. Alright, so GCC 125 modify, if I could spell, make file for use bison and gas. So that's a link command. And yeah, so what's cool about this is if you see here, it says, warning, converting object format from OMF to COF. So back in the dark ages, when Xenix was the only 32-bit thing Microsoft had, back in, I guess, 87, 88, if not before, because, they had data chips. Microsoft knew what the 386 was. They were still using OMF, which is a format for all their objects. Actually, you know what? We have WSL now, so I can probably go WSL. Oh. Doesn't it show list? Okay, I guess my WSL is going to be weird. Or do I have to install it? Oh, yeah, because I think that's right. You get it in the store, and then you open it, and then it says the Windows subsystem has not been installed. See, this is what I hate about almost doing everything from a base machine, just because. Typed in control. Why did it give me a command prompt? Oh, I swear, the more they make Windows think, the worse it gets. So it should be Windows subsystem for Linux. And I'm going to have to reboot, aren't I? You know what, just for the sake of it, I'll do it, but yeah, not happy. Alright, that should be fine. Reboot. So while that's thinking, let me try to fix my 86 box. Oh wow, it won't even do Control Delete. Action, I guess hard reset. It really did not like that. Wow. Alright, let's try that again. Huh, that's weird. What on earth is it doing? I guess it really messed something up. Ah, you know what they say, the best of ideas go nowhere. Alright. Anyway, so we're back here. So, can I run my OS? Now it's going to install it. Alright, so this will take another few minutes. So I can run my notepad, get back to my notes. Very nice. So that sets my prompt. So I've got the Microsoft compiler. Perfect. So now I'm just going to go through and build the rest of the GCCs. So this make file. I guess if I was really smart, I would have taken a look at the other one. So I can copy this bison out here. Since we're not using that anymore. And then the assembler. Yeah, I use a lot of copy paste on this. I did not type all this crap in by hand, but it's still nice to have a make file instead of the usual stuff. But yeah, I can't even imagine trying to build GCC today. It is so out of control. Alright, let's see what happens if we try to build. So this will be more of the same, but this will give us 3 different versions of the C compiler. 125, 126, and 127. There we go. Hello from 126. It's amazing how fast modern machines are. I still remember spending hours compiling this. And now it takes longer to remember where I put things. Oops. I want to delete it. So copy that, paste that. We'll find our assembler. Okay. So theoretically, this one should also just compile. Yeah, when everything works, yeah, it is. It's just great. It just works. All right, so there we go. 3 versions of the compiler. I don't know if it's worth stepping back into like how the compiler actually works with the 3 steps. Because you end up with a hello.c file. If you go b-c hello.c, oh right, I put x so it doesn't step on each other. But you can always run these steps manually, so you get, it's not doing the carriage return line feed, but that's fine. Oh, 2864. So you can see this is the C program here, and then the preprocessor translates it into this. So the big thing here is it takes the version, which is a string that preprocessor knows, and it does like a simple text replacement. So it replaces that with 1.27. So now it's going to print the actual version number. And then the next step tells the C compiler that we're going to translate this from C into assembly because that's what the C compiler does. And now if we type cc002864.s, this is the C program now translated into assembly. So what's cool is up until here, all this is human readable. preprocessor, and then the compiler. And then the assembler takes this from a text file, and then it translates it into assembly. So I can just steal this, paste it, and I guess we can try to run a V verbose. I don't think it's got anything really special to tell us. Yeah, just GNU assembler 138. Now we have a hello thing here. So if I open the hex editor again, and then we go into 127, we'll look at hello.o. No, I don't care. Leave me alone. So this will be the OMF linking file, or the object file. So it'll tell you where it came from, what groups it has as far as text, data, BSS segments. And then you can see the strings in here, and even what functions it's going to call. Oh, come on. Which functions it's going to call, where the linker has to look this up and then resolve it. So if we open file hello.exe, so then this will be the compiled executable, which will have the typical MZ executable header. And then you'll have the next header for Windows NT, the PE, or portable executable. Then you'll see again the segments, text, BSS, data, the relocation. And then you'll see the two strings that get pushed together to printf, 1.27, and then hello from GCC version, and it keeps the %s. So this was kind of neat in printf, is as you write it, that's literally how it gets passed into the stack. So it's also, yeah, how did these things get exploited? That's how. And then there'll be all this code along for the ride, which is going to be part of the startup code and then the shutdown code. Just like there's stuff in here for the default Windows runtime about stack arguments. My goodness, signals, loss errors, math errors, exceptions. And then what Windows API calls it makes, allocating handles, allocating memory, what DLLs it's going to call, and so on and so forth. This is just looking at hex. I'm not disassembling and stuff. That's too much work. That's way too much work. And then, of course, like I'd mentioned before, linking this thing manually, which is this entirely insane string. I think we can get away with removing the no defaults because we do call libc. I think we have an old name, so I don't think we really need it. So we just really tell link what to output, what object file to use, where the entry point is, and then what libraries to link in. Oh, because it's open, that's why. So the files are open from the hex editor. All right, there we go. Oh, wow. So libc.lib. That's so weird, so I had to explicitly tell it. I guess that's part of the fun. And then, of course, hello. And there we go. So if we look at the executables in any of these directories, again, so it's the assembler we copied over, CC1 is the C compiler, CPP is the preprocessor. These are used to make GCC, so I really don't need them now. That's our hello program, and then XGCC is just the program to tell GCC what to do in pieces. Okay, so now that we've got that mess sorted out, I was thinking of Doom. So if I go back to my downloads, the Doom I was thinking of is the one I was using with DJ GPP, where I've done work with the version 1. So it's got to be this one. Yeah. So we're just going to unzip that like this. This one does not come from GitHub. I should get the link. It's SourceForge. So not version 1. Yeah, version 1. So, because I'm old, I used to keep stuff on SourceForge too. And then I lost my email address, so I had to create a number 2 ID. And then I bought my domain back, so I've got both of them now. So, what a nightmare. So I get the link for here. Copy, paste that into my notes. Should almost do this like a section header. Okay, I think that's still unzipping. Yeah, it's a lot of files in this thing. A lot of files. Oh, yeah, and then the Ubuntu setup. Yeah, I guess, whatever. Hooray. So now if I go here, I can type in WSL file hello.o. So this is what that Xenix assembler outputs. You'll see it's 8086 relocatable Microsoft. So it looks like an old Intel OMF file, but it's not because it has the 32-bit code in it. So I'm honestly surprised the Microsoft linker still understands it. It was a accidental discovery. Well, I don't remember making this so complicated. But it picks up CD, so it should know where it is. So I should just be able to type in env. And, alright. So what GCCs do we have? Oh, that's kind of funny. I already have a 127. My memory's going. Okay. Do I have DOSBox? No, I don't. So I definitely need DOSBox to test. Let's go back to downloads. I think I downloaded a DOSBox. I have a DOSBox code. I really don't want to compile it. So I got one here. See, I knew I had unzip. You know what? It just mustn't be in the path. So my DLLs should be here. Okay. So yeah, it's not in the path at all. Wow, that's too much crap open already. Maybe I can minimize all. Not sure if I want to close them all. I guess why not? No, that's fine. So if we go here, and then they moved it. There, they keep moving it. It's about and advanced or something? No. No, no, no. Oh. I hate this. Every time you get used to something, they keep moving it. System. There we go. Environment variables. So much work just to get to this. So we go new /bin. All right. DSCL, DLLs as well. I can never find anything in that Windows settings either. Yeah, and the moment you do, they move it. It is so frustrating. I almost feel like such a moron because it's like, where's the thing? You should know. Alright, so open another command prompt back. So your xtjp, environment, and DOSBox. Alright, so I really don't need this right now, but I want to go ahead and notepad this file all the way down to the end. Guess we can make DOS directory. Alright, I guess I have a blank DOS directory, that's great. So we go to test doom test. Very great path. So it's mounts D to here, change to the D drive. So there's already something in here. So I want to make sure it works. So I go to DOSBox. Alright. And I can't type. That's great. Try again. It won't let me type. What the heck? It's getting input. It won't let me type. Oh, brother. What is wrong with this thing? I use this all over the place. I'm pretty sure I use this all over the place. I have no idea. A scalar, right? Yeah, just the normal. Can I do a 2x? Normal 2x? It already is normal 2x. How about a 3x? That is wild. It won't run. Alright, does it matter? I mean, I can also just make it launch the thing. Just type doom.bat. Oh, that's not going to work. Should have figured there'd be a problem like this. It's calling the DOS extender directly. And this one's an old one because it's the first version of DJGPP. Go 32, go 32. Alright. So if this thing's not going to cooperate for reasons, I should be able to do this. And it should just launch. And it's not. Wow. That was, oh yeah, and of course this thing always changes. Did they give it more than one CPU? Yeah. One socket, 4 proc. I got tons of RAM on this machine, so that's not a problem. Alright, so this version of DOSBox is messed up. That's why sometimes you want to test it on a fresh machine, just because it works on yours. You know, if anything like the Docker story, we'll ship your machine, right? So, let's just go for the regular DOSBox download. Whoa, is that the rain? Wow, it is suddenly pouring outside. At least it's not Miami, so we probably won't lose power. It's just going to be... It's going to be kind of lame. Alright, so let's try this. Yes, next. Oh, you know what? Let me take out the DLLs, just in case that's a problem. Because you never know. Yeah, 2018, we're a little old. Alright, desktop shortcut, fine, whatever. It's not a real computer, I really don't care. Yeah, as long as you can ping the network. Yeah, as long as you can reach it, you can always fix it later, exactly. It's like the first lesson in a big network outage. Get to your devices remotely. Everything else will sort itself out. Okay, and of course this is going to store its config file somewhere else. So we get to do this again. Alright, so put this here, put this. So I can grab this, so mounts. I can't imagine why we really need DOS, so that's fine, just here and then C colon. Come on. Alright. Hey, I can type, that's good. And is it going to work? Maybe not. Wow. You know, I could have sworn last time I tested this crap, it actually worked. That's kind of wild. All right, so we're not doing anything special, so we'll just go VGA only. 16 legs, that should probably be fine. What CPU core are we using? Auto. I don't think I really want to use auto. Because we're going to use such old stuff, we can probably get away with 386. So let's just go 386. Come on. Yeah, it shows 100%, but man, it is stuck. Ah, this does not bode well. It could be because I'm in VMware, but you know, some things really don't like emulators running in emulators. Not sure. Let's just try normal. Yeah, maybe DOSBox X. Yeah, maybe. Of course, the other possibility is it just doesn't work. Let's see. Huh. Is this what happens? I keep forgetting where I was years ago. So I was using 127. Let's see what versions we have. So we got 127 and 139, GCC, GCC new. Alright, so let's GCC new. 2.1, okay. And then with no name, you're also 2.1, okay. Alright. So let's just try and compile this, see if it makes any difference. There's no objects. No, there's no mmake because we're in GNU land. So version 1 should set up for the V1 extender. Let's just see what it does. Alright, so it should compile here, then copy it to the test directory. Oh, there you go. That looks right. That looks very right. There's no audio in this one because this is using Go32. And like, nobody really supported this thing for anything exciting. But yeah, alright, that looks good. So why didn't the other one work? I don't know. So let's try another GCC. Luckily we got many to choose from. Let's try 139. So it's just underscore v139, underscore v139. So make /v1 clean, maybe? Oh, good, we do have a clean, that's good. So now we're stepping back from GCC2 to GCC1. Alright, and do. Well, that worked. Nice. Okay. So we can close that. And then the other one was 127. Okay. So we change our 39 to a 27. So what C flags are we using? Just include in the directory, regular optimizations. I'm not using the math coprocessor at the moment, but I don't think we need to because this is normal. We can add the chaos patches later. Okay, so I guess we're spoiling the surprise, I guess, because this thing should compile with 127. Because that's what was in there. But will it run? And it runs! What the heck? So the Doom that was compiled in there does not run. Wow, okay, that's weird. So now... now we gotta see if mine works. Maybe it was the SDL DLLs. No, but then again, it didn't even launch. So DOSBox, Visual C, release. Can't find it. Okay, I got it. Can't find the DLLs. Chill out. So I'm just gonna try what I had before, because it should fail. So we run this. Oh, we got a blank screen. Don't know if that's really progress. Okay. So let's delete these, or at least this one. Let's see, sdl.dll. So programmed files, DOSBox, sdl.dll bin. Let's try it with this one. Alright, so it's the SDL. Wow. Okay. Let's go back into my downloads. Where is the XDJP version 1? So it's here. So it was test, Doom, test, Doom. Okay. I'm really bad at naming stuff. Because, you know, it seems like to follow some type of sanity. And then there you got 2 tests. Alright, so I'm going to replace it with the one that was in the box. Because I'm thinking I had to have left this thing working. Have to have left this thing working. No? No, it does not work. Okay. And then if we try this DOS box. Okay, wow. So the Doom that's pre-compiled doesn't work. I mean, I don't really need to step into the how and why. It's just interesting that it doesn't work. So yeah, of course, why doesn't it work? I don't know. It is cursed. That is so weird. I could have swore, but again, this is years ago. You know, if I go back here, files. Oh, not DOSBox, not here. It was here. Yeah. When did I? Really? Oh, that's not me. I got the same thing twice, don't I? No, here we go. Okay. When did I make this? No. So files, binary. 2017. I mean, I know, granted, like, it's not that popular. Let's see, all dates. How many people have downloaded this thing? Wow, that's actually a lot more than I expected. It's a lot more than I expected. I can't imagine anyone really wanting to cross-compile to this old piece of junk, but yeah, you never know. It is MS-DOS. Okay, so we verified that. So if I go back here, clean and just recompile. Just one more time. Run the one from the path. And we're in, just like that. With like the most basic emulation too, just 386, normal path. Take the CPU cycles all the way down. Thing's barely optimized, just capital O, because GCC version 1 doesn't have O2. It predates any of this stuff. The math on this is going to be the assembly one. So I probably want to patch that in later. But for now, it's just nice to see this thing's actually working. Actually, you know what? If I do mess with the other versions, do I really need the updated math? I'm not sure. I guess it's like they say, there's only one way to find out. Okay. So we've got a compiler. We can close these things because we know this is working. So I should have my Visual Studio here. So now we're going to verify that our compiler works. So it's xdjc bin cc1. I imagine it's this one because it says it's 127. So let me run one of these commands manually. And what I'm looking for is this, compiled by CC. So if GCC detects what it's compiling itself, it'll write in there, compiled by GCC whatever. If it doesn't detect GCC, then it just types in compiled by CC. I guess I could change it if it detects the Microsoft compiler to print what Microsoft compiler built it. Maybe? I don't know. It's maybe useful for diagnostics, but does it matter? Not so much. Okay, so let's clean. So this should just reproduce what we just built. It's also a V127. The only difference is it was built by Microsoft C instead of GCC. This should have no difference. Oh, that's good. So you completed the whole thing. Very good. You fire up DOSBox. And there we are. Cool. Alright, so we knew this worked, so that's not interesting. So now, we're going to go to GCC 126 and copy this one over. So now if I grab this guy here and do verbose, we should see GNU C version 126. Alright. So this is a cheap way of going backwards in time, is instead of replacing the entire toolchain, you can replace the CC1 part of GCC. You'll be amazed how often I can get away with this crap. So we clean that out and try to compile. Ooh, and we get an error. Okay, let's start a new notepad. File as trouble building with GCC 126. Okay. What did we get? Abnormal program termination. Ooh, that's not good. So that was line 81. Yeah, I don't have any fancy interfaces. I've seen people use Visual Studio Code to like target GCC in weird ways, but it's like it's all pre-canned. I have no idea how to actually build one of those. I guess that'd be kind of cool, but I have no idea where to start. This is weird. It's a structural definition that's nothing. What the hell is that supposed to be? Okay, so let's try that again. Ooh, now it's just program termination. Okay, let's take the optimizations off. No. Signal 3. I'd have to debug it, which means I'd need a real copy of Visual Studio. So, is it worth trying to debug? Is it worth trying to debug? Because I did download Visual Studio for NT. Is this gonna even run? Oh, okay. Maybe. Let's go custom. We don't need MSC. Yeah, sure. I'll take your silly tools. I know the help files are not going to work. It's going to block them. Sample code. I'll skip on the foundation classes. Microsoft Visual C for NT. Okay. So here we are stepping back to 1993. There we go. This is messed up. I have no idea if this would even work. Maybe I should install the samples. I mean, it doesn't matter. It's a virtual machine. It's not real. None of this is real. You do not want to modify anything. So other location. Okay. Do not register the environment variables. Okay. Wow. This is like step back in time. Wasn't it IDE? Or I guess it's App Studio. No, no, no. This is the interface thing. No, we don't want that. Ah, there we go. Of course, it's called Visual Studio. Or Visual C++. Wow. This is so bare bones. It's just like Quick C for Windows. Yeah. At least it remembers who I am. This is messed up. Project new. We're going to call this one GCC 126. That's nice. It was going to put it in the bin directory. Ah. So we have this. So I guess we'll make a proj directory here. 126. Yeah, I know. Some people like this graphical, but yeah, this is the old Explorer thing. Alright, we go to GCC 126. And then, okay. Now we need C files. So it's 32S proj GCC 126. I have no idea. So we're going to grab a lot of crap. So we're going to get all the C, all the headers. And we need the MD file. I think that's all we really need. And then we want the make file just to go get the linking part. Because then this will tell us what files we actually need in the project. Oh my gosh, and there's so many of them. I wonder if I can add more than one at a time. Like if I go replace obj with .c, will this give me those files in one shot? No. No, it will not. Ah, I was afraid of it. It's going to make me pick, isn't it? So I can either add all and then just remove stuff, or go through them individually. Oh, we're adding them all. I know the ones that are like gen you don't need. Let's see. Do we get a nice view? No, we don't. Ah, because why would we? So anyways, debug, yeah. Code generation, 386 please. I'm not interested in your warnings. Okay. Just compile it. See what happens. Wow, that worked great. RTX is followed by via memory. Wow, this works even worse. I didn't mean to close it. Dang it. This is starting to wonder, is this worth the effort? Is this worth the effort? Let me just run this again real quick. I don't think I defined anything. Yeah, there's nothing really defined. It's just compiling. Maybe it's the directory, options, projects, compiler, custom operations. Not really. Don't need C++. Definitely not using precompiled headers. This could be causing problems. And then make sure it includes the current directory. Okay. Try this again. Nope, it's really not happy about that. So I guess the real question is, does it actually compile that directly? The answer would be no. No, it does not. So I was afraid of. I want to edit. So does it compile aux? How did I just build this? Oh, wrong prompt. This is going to be awkward no matter what. Is this worth it? So I don't see aux output in here, so I'm going to remove it. C convert, yes. C decal, yes. C parse, C type check. The preprocessor, definitely not. The C expression, that's the preprocessor again. Combine, CSE, DBX out, emit runtime, xplow, xpmed, xpr. I guess it was really good. I'd just figure out what the debug flags are and just build it back from the command line. Final, flow, fold, constant. Nope, no to GCC. Where was I? Fold constants, gen codes, gen config. Does it really? I don't think so. I don't think it needs any of the gen stuff. Because those are generates. I don't think so. Because all that stuff, it should be the ISN stuff. Global alloc. Yes. Definitely no GNU-lib. No hello. Yeah, these are the ones it generates, the INSN stuff. And then integrate, jump, local alloc, loop. Oh, this MASM 386, this always gave, yeah, you'll save the project and edit manually. Yeah, I don't know what's more painful. the interface for this crap, but this gives the impression that this thing can output to MASM, and it was never completed. So many people died looking for that thing. It's its own massive disappointment. So we got object stack, hot tabs, no output 386, no output Motorola. Oh wow, so many more CPUs. Print tree, recog, reg class, reload, reload, RTL, SDB out. This one will be here. This was just a stupid hack by me to make it happy when it was just System 5 before I put the BST thing in. STMT. Yes, you are. Store layout, stupid, sim out, top level, tree, bar assemble, and version. Wow, wasn't that fun? So we should save it. I guess that means close. Close out of here. I'm backing this up. There's no way I'm doing this again. There's no way. No way at all I'm doing this again. Alright, so I got a zip file of that. Okay. More than one copy. Alright. So we can go back to our precious Visual C++. I guess the only positive thing is with the machine being like empty, things actually show up in the search. Okay, let's compile. And I open the DAF files. Alright. That's easy enough to fix. Fix. I guess just everything.def. Alright, let's try that again. Well, okay. A little bit better. Compiler limit. Too deep, really? Wonder what would happen if we just sidestep the GNU var args. Come on. Are you not going to close? Alright, fine. Be that way. Don't know how to make sys parameter. Okay. You don't have to make it. Don't know how to make sys param. You don't have to make it. Where are you coming up with this craziness? Oh, it automatically did depends. That was nice of it. I'll be darned if I remember how to run that. You want to create it? No. No, I don't. Don't know how to make sys times. You don't need it. Just like a rescan. Scan dependencies. Scan all dependencies. Alright. Let's try this again. Don't know how to make sys param. We don't need it. Because you know what? It's not parsing it like a C preprocessor. It's just seeing it. Or like on the, it's in the file. So you know what? I'm too impatient. I don't care. You want your param file so badly? There you go. I spelled it wrong. Param.h. Oh my goodness. Why? Scan all dependencies. Rebuild. Sys times. Okay. All right. Projects. Scan all dependencies. Linking. All right. I got an executable. I wonder if it even works. Wow, it's a big boy. So it's XGGP bin CC1. Yeah, we're replacing the 127. Yes. Then we're going to go back to here. Oh yeah, see if it does anything. Okay, it also crashes. So we run clean. Wow, that did not work at all. No such instruction as A. I wonder if it's doing the ABC thing again. Oh, of course it is, because yeah, you can't set a custom declare thing. Luckily, I know what this one is. I know what this one is. It's the like standard C thing. And if you define this globally, it screws everything up. So it's ISN output. Go to the file, open ISN output, right? And then just go define CDC, one, rebuild. Okay, relink. I guess go ahead and rebuild the whole thing. Okay. We don't want this one. Just close it. Too many prompts. So we copy this one over here. Yeah, see, I knew I'd seen that one before. Okay. Okay, so now we're crashing again. So we need the individual step. Let's see, so if I run the preprocessor, like so, now we preprocess the file. So now we have the compiler string. So now I should go options, debug, program arguments, like this. Okay. Debug. And we get nothing. That was... I don't know what I was expecting. Can we get like a call stack? No. Restart? So let's just step out. Oh, I don't want to actually step through the program, so that's good. Oh, and then just terminated. Why can't it catch the termination? I don't know what I was thinking. This debugger was going to help. I don't know why I was thinking this would help. Single-threaded, multi-threaded library. Code generation 386, regulated convention. Get strings, press banner, don't need C++, full, using program database. Yeah, there's not a lot of options in this thing. You know what? Fine. Pack the information. Don't pack the information. I don't care. We got tons of hard drive space. Optimizations? None. Precompiled headers, definitely not. Okay. And let's see its rebuild. Fatal error. Cannot open bison.simple. Really? Okay. So that was, let's see, C, proj, GC, doesn't matter, bison.simple. Okay. And recompile. CY is 5. Alright, let's try this again. Okay. So F5, bug. And then same thing, process terminated. With no call stack, no nothing. Ah, sucks. I really don't want to step through GCC. So on top level, is there like a window to watch where you are? But you can't step and look at the call stack. Oh my goodness. Wow, I've forgotten how much this sucked. So we don't care about the top level thing. Oh, a crash is coming out of there. Well, that's weird. Because I thought it was making it definitely out of here. Oh yeah, see there's the compiled by. So we could always hook that. But we have to be coming out of here. There's no debug breakpoint, is there? Wow. Guess that didn't work. I've got to get better better tools because I'll never figure this out using this. Oh my gosh, this is too painful even for me. Because if I step out, it should just step out of this one function. Or we're still reading arguments. I don't care. Arguments. Or maybe we do. Maybe one of the arguments really nails it out. Quiet version, so it prints the version. Else, blah blah blah. Can we get windows for the locals? I can't believe anyone wrote software back then in the 90s. And this is great because we have full memory protection. This would be absolutely terrible. Compile file name, so that's where it dies. Great. So I guess we go ahead and debug, breakpoints, add, close, restart. Now we want to step into function. And then just trace through here, right? So opening files, we init. Nope, nope, don't need any of this crap. Weird, we're back in the top level thing. Huh. I guess it bounces around all over the place. YY parse. Okay. Getting closer. Debug, breakpoints, add. I guess I can clear all these ones. So let's just disable them. Close. F5. We're going to go into the YY parse. I miss the days when there was an animated button. Maybe there is one. There's no tool help. I'm going to kill my finger clicking like crazy here. Although it's kind of weird, this one actually reads the Bison simple. I really don't want to read the whole thing like this, so let me just see if I step out. Terminate. Alright. Let me think. Let me think. Let me make another backup. Phase 2. So it thinks it's going to be a problem with the YY. Let's see. So you know what? Maybe it is a problem with YY. So we know 127 works. So what happens if we copy 126, then we take 127's YY stuff. Yeah, let's try that. Error, right, one right string. Okay. So I'm going to pretend that this doesn't exist. So let's just cheat. And what happens if 1 equals 2? We really don't care about the warn strings. Because obviously this is a feature that was introduced between the two versions. Alright, let's compile. Build index type. Okay. If 1 equals 2. Alright, so this doesn't matter. So we're never going to execute this anyways. You know what? We got backups. Who cares? Normally I just comment this stuff out. But it doesn't matter. I don't have to be nice. Alright, recompile. Really? Just want to make sure this thing got recreated. No. Maybe it's mentioned twice. Maybe it's mentioned. It is. So, same thing. Okay. Let's get rid of all this tree shit. We don't need to warn right strings. What else we got going on above here? Static tree, whatever. Okay. Clean. Try again. Because what I'm thinking is maybe because it was jammed up in the YY thing. Cool. There we go. Hello. Maybe we can replace it from 127 since that one works. Although this is a real Frankenstein monster. So we're going to copy MCC 32S proj XX wildcard.c. Get the H's and the Y's. Okay. I can pin this to start. Wow, just like that. Nice. Okay, so let's rebuild. Compiler limit again. Really? Oh, the var args. Yeah. Alright. Alright, try that again. Okay, so now let's debug. And I'm going to try to step over. Nope, access violation. There's no way. There's no way this thing's worth anything to step through the whole thing. Oh wait, is this where it happens? Is this where we actually are? I knew I had to show you somewhere. So, okay, so we can take a look at memory. Or can we? Ah, too many windows. What the heck? Did it just crash or something? It's because I was getting results, right? It's because I was getting results. F5. And then just step into. And then over, then out. We get a crash. So here we are. Okay. So the locals are just pointers. That's great. So if I go to memory, I guess that's when it crashes, right? No, okay. Access violation, good. Not what that's supposed to be, alright. Just a stuck window. Wow, this interface is terrible. So whatever val is, I'm guessing val's a null pointer. No, it's not null. But obviously, I guess one of these macros unfolds incorrectly. All right, so we have C type check. Okay. You know what? So in the interest of amputations, let's go ahead and did I stop it? There you go. Stop. Right. So I guess I could save this file. Save as GCC 126 crash compile doom in C type check. There we go, very descriptive. So we're going to go ahead and replace that with 127s. So we're going to copy SBCNT project 127 C dash type. Oh no, okay. Okay, so we can go debug and stop. Process terminated, okay. Alright. Copy the file. Yes, please overwrite it. And recompile. Cannot open the executable. I guess the debugger's stuck. Alright. So close. Make sure it's not going zombie. I don't see it. So I'm going to go back into here. See if it can compile. Cannot open file. Why? Oh, because it's running here, zombie. Access denied. Great. Just great. Really? You're type 2. Okay. Oh wow, the CPU on that went through the roof. I had 2 of them at once. Try this again. Okay. So we're going to step out. Access violation. In the same spot. Okay, this is going nowhere. This is literally going nowhere. This is just coffee. Probably should be alcohol. Probably should be really heavy alcohol. I don't know why I was thinking you just amputate enough of the other one. Because where's our call stack? Right, it's under the debug menu. Call stack. Actual parameter list. Build function call. Go back to our call stack. Stop hiding it, or YY parse. It's kind of hard with GCC because they deliberately try to make this thing difficult. So build functions in C type check. So it's the same file. So that's obviously not the solution. Well, that was a side tangent that went nowhere. That sucks. That really sucked. I gotta think about that some more, maybe. So, in the interim, can I just compile this with 127, and then we put 126 back into place? Now we got another one. So we put 127 back in. Yeah, so I wonder if the answer is basically on that line. 126 back in. Another failure. 127 back in. Nah, see, it shows the same output. So it's not necessary. I mean, that means it crashed before even getting to there. Alright, so put 126 back in. Oh, that failed quick. Alright, save that. Put 127 back in, or 27 back in. Oh, it's not this one, I wanted the lib. Add update lib, make sure it's in here. Lib, okay. 126. Okay, another failure on the system file. So we go back 127. 126. Another failure. So 27. Compile. Recompile the video. 126. Boom, okay. Okay. So that means that I can put 127 in place. Then we can compile these ones. All of them, come on. Okay. And then we can put 126 back. And then it should compile the rest. All right. So now the real question is, does it work? Does it work? Yes. Yes. Yes, it does. Wow. IDC Route 22? No. Oh, you know why? Because it's going to be like a demo mod, isn't it? This is the shareware version. Yeah, it doesn't have my favorite level. But we do at the end of the game. Nice. Ah, awesome. So we go to object file. Oh, so we have 65. This is 6 lines. So we're 92% with GCC 126. Yay! My stupid notes. I've already forgotten. My mind is going, yeah, 92% Doom. Okay. So now that we established that, can 125 compile anything? I'm thinking the answer is no. I think I'd almost be surprised if 125 can compile one file. Oh, it did a couple. It did a couple. There's got to be some way to do this easier. This is a lot of typing, and I don't like typing. Just not seeing it at the moment in my head. I thought, I guess. Just copying the driver files, yeah. Yeah, this is really not going well, is it? I mean, it's compiling some of it. More than I expected. But not going that great either. Oh, not going well. I'll let it go up to 10. I guess I hate myself that much. Oh, this is not working. Well, I guess I'm kind of surprised it compiled anything. Yeah, these are all things 126 could compile. I've got one. And I'm sure these objects have got to be tiny. Yeah, it's not doing anything useful. I mean, I honestly wasn't expecting much. I guess just put the 127 back and just finish it off. Let's see if 126 back in place. See if any of the stuff being compiled by 125 even works. It might. Yeah, it did. Because in my initial testing under Windows, 125 sucks. 125 sucks a lot. Yeah, 125 is pretty terrible, but 127 is pretty solid. Okay. So probably just turn this back to 127. That at least does something. Probably should do is get the yeah, I need that for FTP because for some reason my FTP doesn't work locally. What is it? DOS Doom, I believe it is. DOS Doom? Nope. Doom. Or Doom New, okay. And then go through the commits and fix the M fixed. Actually, I didn't really need the diff. I could just go grab the file from here. So I can grab the header, download. So here I think I just wrapped it into Wacom assembly. Redefine, because I wanted to force the C everywhere. Then mfix C, download. And then yeah, this is the crap I got from AI. But I think it's elsewhere too. Not sure. But anyways. Not sure. So download fixed. Yes, yes. Clean fixed. That's what we want. This makefile is a nightmare. It's the one from id. I just never altered it enough. Okay. Oh, C++. One day I'll have to fix that. For now, I just don't care, so. C++ify it. At least I know it's definitely compiling it. Move all that. Because the problem with the really ancient GCC is the G++, the C++ thing was not included. I don't think it was even, it may not have existed yet. So it doesn't know how to handle C++ style comments. I don't want that. Don't care. Yeah, and there's a conflict with the stupid libgccs. I can't say I'm surprised. I think I've been down this before. I must have. That does not look right. That does not look right at all. Oh dear. Doesn't matter really. GNU lib. Okay. Edit find suffix C. Yeah, not much going on there. I wonder if it really wants it to be built by. It is fix FSI. Double A. Return integer of A. Long int. SI type. What are you? You don't declare a type. I hate this old C code sometimes. These implicit types. Alright, so GCC v127-c fix dfsi. Well, that's good. It does at least do that. So, go back to the thing here. Fixed. Wow, okay, that's not what I was wanting. So I want this. I probably have to tell how to build it. Of course I do, because this makefile is just hell. I forget how the recipes work in GCC. It's GNU, or GNU-C, I should say. 83 line error. 83. Oh, yeah, because I didn't put a new line on the end. No rule to make it. Not surprised. XDFSI. Okay. Does it work? That would be no. Wow, that was a good little failure. Wow, no, no, that does not work. I wonder how much hard drive space I just blew up. Ah, only a couple 100 MB. Okay. So I just recently went through this, where those files have to be built by a native compiler. But that all changed in GCC 2. So I wonder if I can just build it with GCC 2. Error 3. That's good. Wouldn't want to get like an error message that made sense, would I? The preprocessor died. What? Really? Am I going crazy? I'm pretty sure I got rid of that part. Wow. Okay, let's not optimize. Okay. How about 139? Alright, that one was happy enough. Can I optimize? Wow, okay. That's weird. Is it going to work? Not sure. It might be close enough to 2, or a back-ported version of 2, but it might actually work. So let's just clean, recompile. At least on modern computers, this is fast enough. Okay. Boom. Okay, that worked. So the reason I knew this one was definitely going to have problems is goes back into here. All the transcendental math stuff. These things here. Does it have a note? No, it doesn't have a note. But back when GCC was new, almost nobody had a working GCC, and it was considered too unstable, too much of a like a beta to have people go ahead and like rely on it. So you were always compiling GCC from another C compiler. So for the math functions, you were expected to compile it on your system compiler. So if I look at makefile Microsoft C, we go through here. Yeah, so this is building the library. So all these crazy little functions and stuff, they're all being built with Microsoft C. The only thing that GCC builds that I used in here was the Hello World thing. And I know this from, like I said, from a real world test. Let me go find GCC. If I go grab 127 from here, I did make a binary release. So this big thing here, this benchmarking thing, because this is called floating point, and you have to link it with GNU lib. So that was the one thing I found was you could build it, you could link it, and it never ever ran properly. And the answer was it had to be built with the native chain or the native tools. So in this case, Microsoft C. Come on. And there's definitely some mismatch going on with DJGPP. I'm not sure what they did for native stuff. I guess convert objects? I'm not sure. Because essentially DJGPP is like its own platform. It's its own thing. Yeah, so if you go to type environment variable from here, so if we go to project Skystone. Yeah. So this will call the built-in thing 8037. Okay. So I can just compile from here. Oh, good grief. I hate this stupid virus threat. Half the reason why did your machine run slow trying to develop stuff. That's why. Okay. Alright, so it compiled, it lanked. And yeah, so now this should be able to give me a benchmark number. Yeah, go away. I guess while that's thinking, because the other one to test it was this, the phases of the moon. Oh, my goodness. Another virus scan. Really? There we go. So this does call a lot of math. Oh, there we go. Benchmark completed. With this old version of GCC, performance is absolutely terrible. It's more of a, wow, it's working type of thing. But yeah, you absolutely need that library built by a non-GCC compiler. Maybe it still bugs. But by version 2 of GCC, it's capable of building one of those math libraries on its own. And I know 1.40, I'm sorry, 1.40 takes a lot of fixes from GCC too. So maybe 139 as well. I mean, it must because it ran. Yeah, because it definitely ran. Okay. So that means that we can go back into here. And now I don't want soft floats anymore. I'm explicitly taught I want a math coprocessor. Cool. Still working. Much to my amazement. So this is kind of neat. So this is built with a 1988 version of GCC. But now it's using the math. So that's fine. That's fine. But does this make for anything interesting? That's the hard part. Because I'm really not sure if any of this is even remotely interesting, but at least I think tying it back to Doom kind of makes it interesting. Kind of. Hmm. So let's get rid of the tables. Okay, so now init point to angle should actually calculate the table, and now it's blank. So compile, or clean compile. What's this? ATAN. Oh, of course, because now we're actually really using math. It's back here. So lids, we add lid math. So now it really needs a 387. Nice. So everything looks normal. Nothing looks messed up. Okay. So that's the first step. Now we find the next one, which is not this one, but this one, init tables. We change this to a 1. Then we want to find this table. So we just rename this one for now. And we'll just make this one empty. And this is the next table. Set find, put an X in front. Okay, so that will have replaced those tables with something that needs to be calculated at runtime. So clean, recompile. Nice. So this also means now we can change the value of pi. Yeah, because here's where pi is called. So if I do something stupid like let's just put an X in front. Clean, recompile. All right, there you go. So this is what they call the non-Euclidean version of Doom. Because pi is not equal to 3.14, and so on. Yeah. All right. It's kind of hard to control because it always wants to hit walls and stuff because you can't walk straight. I like how the bullets actually travel in straight lines, though. Actually, I guess that's a way you can almost cheat because you can move stuff out of the way if you can hit it remotely. It's so wild. Alright, okay, so I don't need to play that. I've already done a way longer playthrough than needed for that. So we can take off the XPi. Let's go back to using normal pi for now. Clean, rebuild. Okay. So that should give us something halfway normal. And then tables. I guess I could just delete all this. Just to definitely prove that it's definitely working. Find tangent. And this one goes as well. And hopefully we don't get any missing symbols. Nope. No missing symbols. Nice. So I've restored pi, so this will look normal. Fantastic. Hmm. Okay. So I guess the next thing to do is maybe look at the chaos thing. I'm trying to think if I saved it. I'm pretty sure I saved it. It's changed all my dates and times again. Damn it. I thought I called it chaos. Hmm. Nope, it's not here. Well, this sucks. That must mean I did it downstairs on another computer, right? Or it's right here. Is it? Yeah, okay, okay, okay. So I think I can copy paste like this. Whoa, that kind of sucked. But okay, I can work with this. So I just inserted extra lines. But, you know, outside of just looking ugly, the compiler won't care. The compiler won't care. Okay, so we just gotta go find all the times we use our int tables. So here we init to 1.0. Okay. So it's here and the stuff. Oh, wrong window. Notepad st stuff. St responder. Okay, so where's this coming in place? strdqdm. So player health to 100. Right here, okay. Yeah, and then that will return reality, because otherwise it falls through. And then the next place is calc pane. So let's see. Turn last calc. Okay. So old health. Okay. So this should sit between here and here. What? And that one pasted fine. What the heck? Okay, so player health is less than 101. And it tables to the health divided by 100. Else, init to 1. It's probably wrong, but you know what? It's going to give the same answer, so I think it's fine. That's it. I think that's it, right? Let me just make sure. This is the player T players. And this should do the thing where it updates it with the string. Oh yeah, there we go. So this will print the string. Okay. I wonder why I did that. I wonder why I did that. I think I need to define my numbers. I guess I can put them here. Who needs to put defines on top, right? So by default, Doom uses this. So what I found is that approaching the value of 3 makes it a little bit more crazy. Yeah, see the project name. Oh, that's old, sorry, yeah. So as a percentage of this is how it calculates yourself going back to normalcy. So let's see, we should be able to recompile. There you go, pi equals normal. And then if I go ahead and injure myself, there, pi equals 3.11. So you can see some of the floor acting weird. No, shoot me, not each other, idiot. Ugh. I'm just gonna go step in the green goo. Alright, there we go. Whoa. A little too dead. So what's my health? 30%. Okay. Come on. 21, 15. Oh, I'm gonna get killed. So yeah, you can see the world's very warped. And then if I just pick up a health pack, there, the world just suddenly adjusted. Perfect. Wow, that's kind of weird, the screen tears, huh? So if you stand by the building, you can watch it deform. You see there, pi just fell 3.0002. Cool. There you go. Not too bad. Not too bad. I don't want a 126. I want a 127. So that I can just copy these back into here. Clean out. Then put 126 back into place. And recompile the rest of Doom. Run DOSBox. And there we are. Nice. So that's part of the reason why I was fighting with that stupid floating point thing. I didn't want to rely on assembly, I wanted to own C. And it just shows you how fast machines are, where it can calculate that whole table in real time. So I don't even store it. I mean, I guess I could, but where's the fun in that? So, yeah, obviously I'd need 100 values for each one. But, you know, a good 387, you can crank it out in, you know, sub-second. So while the screen flashes, who notices, you know, the pause while it recalculates all those tables? It's neat, you can see that everything deforming. Maybe one day I should try replacing the table math entirely. Maybe. Not sure. I need to take a bathroom break, so I'll be back in a moment. Okay, well that was fun. That was fun, was it not? Oh wait, it might be the opposite of fun. Yeah, probably the opposite. Pretty sure I have Python on here. Downloads. Oh, I do. How convenient. 32-bit should be fine. Install for everyone. Oh, I should keep my notes up to date. I guess part of how and why I could do a video. So I'll never remember this crap. So build WAD. Install. It's Python too. Yeah. That's fine. Registered extensions. I don't know. Yeah, just do it. Just do it. Then there should be a mingw installed. I guess let's extract here. Where did I get that from? I think it was back on GitHub, wasn't it? QEMU. I think it was this one. Binary build. Yeah. Because it's such a pain in the butt to trace back the install tools. Like a good Docker user, I uploaded my tools. Okay. So we'll save that. So if I find mingw installed, so I can just cut that. Yeah. Now we're going to try something really crazy. We're going to build the WAD file. mingw3, so I can go. Oh yeah, yeah. It is kind of fun sometimes because you can really abuse this stuff. Yeah, you know what? I can also probably show like building Linux and stuff. Maybe it's more fun than building the WAD for Doom. Hmm. Let me just see how painful this is. I think this should just work. If not, yeah, you know what? Let's build some Linux. So this is the free Doom assets that I took and modified to work with the levels that John Romero uploaded. So I should be able to just type make. Oh, because the Python's not my path. Of course. And then what I started to do with this one is I started to use some scripts and programs to get the dimensions of their assets and then just create blank images with black borders around them. Okay. So now we should have a WAD file. Just to make sure. Yep, just created. Doom.wad. And then I want this into, oh my goodness, xtj test doom test. Okay. And then I want to get rid of the demo one. So we're going to delete Doom 1.wad. Okay. I've been definitely playing with Doom way too much lately. Now I can run Doom. Ah, there we go. I'll have to upload this definitely because this is it's familiar enough where you can recognize the levels, but I kind of like the aesthetics of everything just being blank. And then of course, once when you take damage and pi starts to change, see you can see like the lines are no longer straight. So back to reality. And then as we take damage, yeah, I try to put labels on what the walls and doors and panels are. It's a little hard to follow if you really don't memorize the things. That should say wall. And that says door. So you space up to it. There you go. It's a door. Past the Doom monster. Oh, look, a door. And then this should say button. Oh, well. Yeah, that surprisingly seemed to build too well. Yeah, I guess it still had everything in there. Oh, well, whatever. It only takes a few moments for this to generate. It's really nice having a fast modern computer. Because, wow, this must have really sucked in the 90s. Especially, yeah, just leave this thing running in the background. Just ignore it. It's fine. Totally fine. Just close some of this stuff down. Yeah, I already put Visual C on the desktop. So going back to my SourceForge page, building and running Linux on Windows. I still think this is one of my favorite things, and it's a shame it really didn't get the, in my mind anyways, and of course I'm 1000% biased, but I don't think this gets the attention it really deserves. So it should take a few moments to download. But this is a copy of a bunch of the old Linux kernels and the tools to go ahead and build under Windows. Let's see, did that finish downloading? Yes, it has. Good. So, downloads, this A out. So we can go back to here and then just simply drag and drop. I guess this will take 3 minutes. Oh, we ain't got time for that. No, 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 no. Alright, that's still making a WAD. So if I go unzip users, Z downloads, A out. Yes, replace everything. I almost feel like Terry here with all these flashing things going around like crazy. Too many windows. Alright, let's close some of this crap off. So I included a lot of crap into this thing. Let's see, so my environment variable at least picks up regular path. A copy of msys. Now we're at GCC lib. Okay, so I type env. GCC minus v. Alright. So we have multiple copies of GCC. But you know, we never tried to see if 127 can build anything useful. So this will be kind of fun. So we can copy all of our CC1s to old. So let's see, test. believe if you type in run, it will compile a hello world thing. Okay. Because originally what came to me is like the idea is that a C compiler just reads text files. There's nothing special about it. Or at least it was back then. I know they've really gone out of their way to make it incredibly complicated and unwieldy and all kinds of modern conveniences for modern audiences type thing. Ugh. Especially when GCC went C++. The worst. I need another copy. Hang on. But so anyway, so old Linux built with this GCC 1.4. I don't think you're gonna find much trace of like distributions and stuff because by the time the distribution started to become a thing in '93, it already moved on to version 2. But for a brief while, the beginning of the genesis of BSD, you see it in like commercial stuff like the Dell Unix and stuff. Mock microkernels. Everyone is using like 139 and 140, which is kind of crazy. Yeah, does that take care of everything? No, it doesn't. So let's see what happens if we go into our compiled versions and copy GCC 127 CC1 onto the A out spin CC1. So let me check. Yeah, so that was running CC1. Okay. So we replace that compiler. So now you can see it just compiled a simple hello world version 127. Okay. I'm not expecting this to work, but you never know. So in this package, I have a bunch of kernels. The 01's not a real 01. It's that Chinese guy's re-implementation of what he thinks 01 could have been. The one that just prints A and B over and over again. But 0.10 is the real deal. So if we go into here, I do believe we can just type make. Wow, okay. And that did not work very well. It really doesn't like volatile, huh? Yeah, I guess it really does not like volatile. So I guess we're in init. Oh, we didn't even make it out of init. Nice. So let's see what happens if we try to define volatile as being nothing. It's probably not going to let me because it's a keyword, isn't it? Before Windows and Microsoft got popular, yeah, all incomprehensible. No kidding. Yeah, no kidding. Ah, but nothing in here is volatile. So it's got to be macros. It's got to be macros. Yeah, you gotta love the old Linux stuff. No, it's underscore exit, not exit, because there's no C runtime. Okay, let's put the compiler back where it was. So if we copy old, the bin, replace all the CC ones. So we can't do any goofy experiments on this one, but we can type make. And now we're compiling Linux 010 from Windows. There we go, all done. It's very tiny back then. I know this is the part where I kind of like fell down on this is like how to run it. You go to A out. Did I have QEMU? I think I had this like all like preset to run. So if I run this, child 3 died. Well, that didn't work very well. Let's try that again. There we go. Nice. So this is using QEMU, BIOS, hard drive, blah, blah, blah. So back then it was doing the floppy disk image build. So that's where you see where it hard sets the root device for the hard drive. And yeah, I was able to get, these tools were a little weird, but yeah, all the GNU stuff and all that working was pretty simple. So what's crazy about this is that you could, I haven't bothered doing it from NT or OS2, but all these tools and stuff absolutely could be compiled by Microsoft C. So you absolutely could compile Linux under the 1991 version of NT or any of the 32-bit versions of OS2. Yeah. So when he used Minix, you didn't really have to use Minix, but you know how everyone puts their nose up. Oh my God, the thought of like using Microsoft C to build your little hacker OS. But you absolutely could do it. There's no reason why you couldn't. So yeah, there we are. We run hello world. Of course, there's no halts because this is back in the old days. So you just run sync a lot and then just power off. So just to make sure we did what we thought we did, so it's clean. This just takes forever for the make file to process. So we no longer have a Z image, so if I try to run this again, it should fail. There we go. I don't know if we get a standard error. Yeah, there we go. The image file is not found, or invalid argument, but either way, it's not found. So I always thought this was cool, and it really wasn't that hard to set up either, surprisingly. The hardest one I think was the last one. I think I had to configure that one actually on Linux, just because of the build path and all that. But yeah, you go through all the rest of them. So Linux 11, yeah, there's an image there already. This is the one I originally started with this idea. So what I did was I captured the build process and then just replaced it as a command file and then just slowly started working through all the steps needed to compile Linux. And then just kept building and building on it until I was able to, replace the makefile with this simple script that has no error checking because it's not make. But yeah, I was able to compile a kernel, and then it's just a matter of going through the tool directory, porting the build program to run on Windows because of the way files are handled between binary and text mode. And then yeah, after I think 3 days or something, and I was able to just type in this, and there's a good script. It's able just to hammer out and compile the whole kernel. You gotta love modern machines, just like that. That is so fast. I want to say I started with the 012 back in the day because I can remember the version number jumping. It might have been 11. I mean, it's hard to remember. It's so long ago. But yeah, so now if I run the Linux 11, there we go. Booted up no problem. And of course, there is no halt, there is no shutdown. It's just the way it was back then. I think in their init main you can make it say stuff. Okay, yeah, so here's the proper init. So buffers, whatever, print free. There we go, put in some rude graffiti. Then rebuild it with a script because why not? Launch the emulator, and there we go. Wow, built on Windows. So just in case it looks like there's any, sleight of hand or whatever. And that's why I thought it was really cool because you don't have to know how to use Vi. You can just use Notepad. I guess I really got to figure out that visual code thing for doing GCC plugins. Because I'd imagine this should be pretty awesome because these old versions of Linux are like almost human readable. And there we go, just compile another one, why not? And run O12. Yeah, I remember when they started this. You want to see these VGA modes? No. And there we go. Linux O12 compiled by GCC 140. I probably should go back and find all the GCC predefines. I'm sure there's ones for time and date. Or if not, just add them there. That's good enough for now. Yeah, let's try Linux 109. This is when Linux started to get big. 6 megabytes. Wow, so crazy. So you can see I've got the build, the piggyback, and then the extract. Because the build process started to get so big, that's when they started to include the compression and the crazy piggyback thing, where the bootloader loads the thing to decompress and then jump the memory around. It's so complicated. Yeah, let's use GCC 2.58, which, for a long while, it was my favorite version of GCC. And that's back like when there was the Pentium stagnation and all that. There was this huge period where, GCC was going nowhere. Oh wow! I looked away for a moment. Darn, that compiled fast. Yeah, exactly. It's a bunch of diskettes. How big is my kernel? 170 kilobytes. I just want to see something real quick. So just clean it out. I can remember getting these kernels and stuff. It would take like all day to compile on that 386. So I'll just rename the Z image, and then we're going to go zip -r linux 109.zip linux 109. So how many floppies? 2.4 megabytes, 2 diskettes. Time to call it for a day. Alright, no problem, man. Thanks for watching. Hopefully it wasn't too painful. The rest of the stream tomorrow morning. Okay, cool. Yeah. I'll probably just build some more kernels and stuff. I guess maybe just show off some of the stuff I've done. Yeah, catch you later. Have a good one. Night. Because it's 9 o'clock here in Scotland, so everyone else in Europe, it's coming up late. Oh yeah. I work weird days. So for me, today is my Saturday. For everyone else, it's Sunday. So tomorrow they got to go to work. Where Monday is my Sunday. Wow, that gets confusing sometimes. So you can run Linux 109. Here we go, calibrating delay loop. And there we go. Boom, into the kernel. And up on a new file system. Yeah. What's run me? Oh, I guess I had FTC on here. Is there a halt? Shut down. And it's 0. No. Not much of anything. It took a while for Linux to get kind of serious, but back in the 1.0 days, even it was still a hacker project. People really didn't take notice until, yeah, version 2. Version 2, everything changed. That's when it started to get corporate. And they dropped support for A. Out. I guess that being the other thing. So let's just go back and just pick another random one. So this is 97. Yeah, way before. Yeah, I've been using Linux basically, not since the beginning, but pretty darn early. And what's funny though is I had no idea about 386 BSD, NetBSD, any of that stuff. It's amazing how isolated it was. Because I know when people read that thing from Linus saying that if he knew either one of them existed, he would never have bothered wasting his time with Linux. And it's like, I had no idea either. It wasn't just him. Yeah, it's funny when you read the old project names and they get more and more obscene. Oh, yeah. Yes, they do. Oh, yes, they do. So let's see. So if we look at lib and go WSL file O. Yeah, and this is where you'll see these are the magical A.out little endian. Yeah, it's easy to miss. Yeah, I mean, a lot of this stuff was on the internet. I mean, it all was for Linux because that's where it was spread out from FTP servers. But like, really got my big start because back then I had the Minix thing, the boot root floppies, and I was having so many problems. It was either going from 11 to 12 or 12 to the 95. There's nothing in between. The kernel version really did just take a massive leap back then. And I couldn't tell if it was my machine, the compiler, the libraries, or what. So that's when I took the Minix thing, then did the 386 patches, built GCC under Minix, and then cross-compiled all that crap to find out what was the problem? Damn, it's scary because it's like it has to be like 92, late 92, maybe early 93. It's like what, 31 years, 32 years ago. It wasn't hardware, I remember that, but I had some weird instability and I just couldn't figure out what it was. So I went through all this hell to build this stuff, and it was like, I guess an exercise in learning how to do it, but it was not practical. So modern day stuff uses something called ELF, which they got from System 5. Let's see, I should have my Ubuntu thing. I don't have a C compiler, do I? No, of course not. I think it's Build Essential. Yeah, and as much as everyone shits on Debian and Ubuntu and stuff, unlike Red Hat, it's still going strong. Oh man, an Apple II in '96. Wow. And I was complaining about a Commodore 64 in 1990. That must have been rough. But then to go from 8-bit to jump straight to 32-bit, that would have been huge. Because man, I can still remember getting my first 286. It was so amazing just how large things were and having a hard drive. You know, 20 megabytes. It seemed like infinite storage. And then very quickly, very quickly, ran out of space. But Stacker was a thing, so that was nice. Have enough room for DOS, couple games, and then Windows, of course. And then writing them right, and ugh. But even then, at least I had a Pascal compiler. Yeah, no kidding. You'd be jealous as hell, man. Oh, an Apple II, though. Yuck. I mean, I know a lot of Americans love the Apple II, but where I grew up in Canada and stuff, like nobody had apples. It was such a, again, that's the thing. There was no like popular culture, no television shows or anything really depicting the stuff. So like, if you didn't know them in the real world, the stuff didn't exist. And seeing the Apple II stuff, it was just so primitive compared to the Commodore 64. So it's almost funny. People are like nostalgic about the Apple, but it's like, yeah, no, thank you. Yeah, just compile C, hide it, C. Wow, and see how complicated GCC is now. All this noise, all these options. It's just too much. It's just too much. And then, wow, what could go wrong? You've got version 13. It relies on this GMP, and then the MPFR, the MPSC, the ISL. Gee, I don't know why my software doesn't work. And then, yeah, so here's what you'll see. 64-bit LSB relocatable. Good old System 5. And getting this out of the way. Yeah, and then back in the day here, the GNU tools were all about A.out. So it's kind of funny is that a lot of the PC stuff did not modify the GNU assembler. That Xenix thing is the real rarity where we started. Um, yeah, almost nobody modified gas. Everyone would just find a crazy way of converting A.out into something they could run. Yeah, it's amazing any of this crap does work. So now I can show the objects. So if I go to project, Fibonacci, why not? And make. So hooray, it's a Fibonacci. Oh, it cleaned up after itself. Sometimes I'm bad about that. Alright, so now I should have all the steps. There we go. And then, yeah, just the fact that this crazy assembler outputs into this format. Like I went over this at the beginning, yeah. And there's the fact that Link, despite being all Windows NT focused, someone left the options in there buried deep to still deal with OMF. I think they fixed it in either 2003 or 2005. Because it definitely does not work with modern Visual C. But it's just a linker, so as long as you can link with the older linkers, you're pretty much in. Now I know there's different calling conventions for GDI and all that, and I have not looked at it and I have not messed with it, so it's basically just text mode only stuff. I'm not sure what the deal is with some of it. There's some other weird stuff. I forgot the Infocom thing. It doesn't work properly. Yeah, so you see this invalid fix-up thing. Don't know what it is. Try to type something in. Oh, I don't know the word quit. Something weird overflows while either building or assembling it, and it just does not work. But what we can do, because we have infinite copies of this crap, is we can copy the A.out bin CC1 to GCC 127 bin CC1. So that was input. Oh, yeah. Then just recompile it. Now it didn't complain. Yeah, so now it works fine. So that's something weird about those ancient versions of GCC that you can definitely see 125 barely runs anything. 126 It's almost there. 127 is enough to run Doom. But this stupid Infocom interpreter can't do it. Cannot do it. But, you know, GCC 140, no problem. Yeah, I wanted to do the GCC 2s, but I was having some weird problem with the ELF tools. I have no idea what that is, but I don't feel like tackling it tonight. I feel like I already wasted so much time for everyone to try to fire Visual Studio and try to debug that weird bug with GCC. It's almost just not worth it. But I should have 386 BSD. I think the hard part is trying to figure out how to get a kernel to boot. Or at least under emulation. Do I have mock in here? I thought I had mock. Oh, mock. Maybe it's under here. No block. Ah, sometimes I use the worst names, or that's what it was called. So let that download. Oh, right, I don't have 7-zip command line. I must have installed the other one. Which means this machine wasn't, it was not playing when I started. Means my notes are kind of crap. Oh, it's a whole tree. Nice. I can exit from there. So this should be the 386 BSD kernel with just enough stuff to actually compile it. Because the tools and all that are all laid out weird. The BSD people try to like unpack everything and get very fancy. It was just so silly. Okay. Go to command files, make files, make clean. Okay. Let's see if we can make dirt and h no file. So let's definitely do something stupid. So it includes this? There is. No, I don't want to open it like that. I want to copy. There we go. Something's not right, or it's not seeing itself. So it didn't want to be there. So let's undo that. I will just copy this one. Maybe when I ran make clean, maybe that made it angry. Okay, that's better. So if I remember, the configure program was nothing but trouble. And looking back at it now, I'm pretty sure it's got to be ASCII file problems. Well, there's a lot of them. Oh, yeah. Helps if you put the path in there, right? Weird. I could have sworn I had this working. This must have maybe I uploaded the wrong one. I386, I386. Hmm. Okay. Ah, there we go. We got a kernel. Nice. So let's try that again. See if we can delete that. Well, that was weird. And there we go, just like that. We have a BSD kernel. But unlike Linux, they don't floppy boot. That's half the problem. And from Windows, I just don't really have a good way of I don't have a good way of injecting them. But yeah, they should still be all the same. A little endian. And I'll get the hex editor. So 386 BSD. So good here. Open. Oh, I didn't realize there's that much padding at the front. I think I did have like a working system and then some floppy trick or something to go between them. Yeah, I mean, it's a binary kernel. You're not going to see anything that interesting. Other than, just like the Linux thing too. It just compiles so much more easier from here. But yeah, part of the problem is just getting the kernel onto there. Because the other thing with Linux is that for when the boot and root floppy thing just wasn't working anymore, there was bootloaders under DOS that could load Linux kernels. There's supposed to be one for BSD, but I never got it to work under emulation, and it definitely does not like 386 BSD kernels. And unfortunately, I just don't know enough about this stuff to effectively do this. So this version of Mach is, I guess, expecting to be already someplace where it can be built. So I'm not expecting this to build. Remember, you don't build it in the top level. It's an object. It's been way too long since I messed with this. Oh, okay, that's interesting. I wonder if I was using this from the Linux one because I see GCC 258, which I can almost guarantee is not here. So let's try this one. Yeah, I don't think it like that. Do not think it like that. guess I didn't fix the. I guess I didn't fix the make file. Yeah, but obviously I have this, so I should be able to build. Yeah, so the BSD tools are nowhere near good enough. Yeah, no such file for low core. So we can just kill that. Because that's the other thing with Mach, I remember that they also use like a version 1 kernel, or 1 GCC. And that I thought I had this thing working with 2.58. Yeah, there's obviously more going on than I can remember. And sometimes it's just so bad about not writing stuff down, and then years go by, and it's like, how did this work? What happened with this? Hmm. Oh, this is just like the original sources, isn't it? Or is it other stuff like? Yeah, because a lot of the original source code for a lot of this stuff is all gone. People deleted this stuff because it was so massive. And yeah, the stuff's like trivial. It's nothing. I'm surprised people still download it though. Any tools? Yeah, back when GCC going ELF wasn't that fun. Oh, what a nightmare. The big binary conversion. What a nightmare. That's definitely when I was like, you know what? Just download a new distro. Your life is not worth this shit. It is so not worth it. I guess I have a Slackware mirror. I do. 2016. I mean, like, no wonder I don't remember doing any of this stuff. MinGW 295. Wow, that's super old. And then the same Mach. That's weird, because I can distinctly recall building Mach, though. So should it go out there? Go to details, and you should maybe see CC1 and stuff. Nah, this thing does updates too slowly. Yeah, he can't see anything build. At best, you'll just see this. So that's how you know it's compiling. Oh, there we go. It's done. It's spelled right. So I guess the low cores are not happy. UUD code. Oh, that's right. I had problems with some of this stuff. WAP generics missing, huh? Hmm. You know, I wonder if my files are being edited or something. It's like clearly files that should be there are not. I mean, obviously you can't have sim links. Hmm. Obviously this is a bad idea. It should just include since there's no sim links here. It needs UUD code. Where do I have a copy of that handy? Oh, I can just text utils? Search? No. Char utils. Of course. I really hate that things have grown so freaking massive that everything is gigabytes upon gigabytes, but they cut out stuff like UU code. Like, really? We're not saving anything. Yeah, so obviously there's some cheating going on here. And if it's got different paths, it's totally going to freak out. Good grief. No, I don't want one. There you go. Is this one standalone? No. Small Unix programs? Hmm. I almost could use an Ext modem thing. Oh my goodness, could it make it any more Unixy? Oh my gosh, this compiles with anything, it'd be a miracle. Oh yeah, I forgot we've left that thing building alive. And it compiled. Nice. Okay, PWD, ain't got it. Remove it. Function warning error. Dereferencing pointer to incomplete type. Oh my gosh. Let me guess, we're setting the username? Yeah, well, we're not going to do that anymore. Expand file name. Handle tilde user. Yeah, you know what? Let's not. mkdir. Yeah, none of this crap applies under old systems. We can set the permissions. Sleep? Really? Wow, could they make this thing any more Unix? Let's not sleep. There we go. I just want you to decode files. Am I asking too much? Okay. So let's see. So our UUD codes are still there. So let's build the GCC one again. Oh, I probably should have captured the errors. Oh well. Well, that's disturbing. Because now I remember that the a lot of things tied to the floating point thing. Yeah, yeah, it's not just me. Oh, you know what it is? Because UU encode's not opening in binary. I should have remembered. Back to this again. No, you can read in text. Oh, if define MS-DOS. Great. So now I should be able to decode. No difference is detected. Oh, that wasn't it. That was not it. That was not it. Because I can remember part of me wanting to rebuild this without the floating point. Because it's like everything has a floating point coprocessor now, so you really don't need it. Yeah, you see it's the same transcendental math. But what was funny about these is that, what do you call it? They're proprietary Intel files. They're not supposed to be out, but Next kind of fucked up and they released them all. You look at Darwin, and then it's in before they call it X and U, it's just kernel. And then look for arith. Oh, this thing doesn't index. This is so annoying. So it's like I386 floating point. And they move stuff around all the time. There's obviously no thing here. This is a mock dependency, I386, floating point emulation. There we go. Floating point arithmetic. So Apple slapped their header on top of everything. And then Intel Corporation proprietary software. Under non-disclosure. Whoops. So the mock people just released objects files of this stuff. But Next kind of didn't get the memo, and they just published it. I almost wonder sometimes if that's one of the reasons why these old versions just up and disappeared. Because they definitely published a lot of stuff that very unexpected. So yeah, if you ever wanted to see floating point emulation written by Intel, you know, it's 386 assembly. This is it. All hiding in Darwin. Is it useful? Not really, but not really. So let's see if I go back into here where we link. Now it's copy it. Alt2.cmd. And I know this is part of my screwing stuff up, but div mul definitely is one. I'm not sure all the rest of them, but whatever, it doesn't matter. Lip SQ, reg, round 6. I'd imagine round is 1. Status, okay. Oh yeah, FPU end. Okay, that's the hint. So let's trash all those. So low core, FP kind, FP thread, FP no exit floats. So what happens if you just put FPU end? Oops. And FPU start. Nope, that did not help. That did not help. Bummer. So PCB, let's see, FP kind. Oh, it's a mock kernel. I was just curious to see how bad this is. So this is a mock kernel under Windows trying to compile it. Yeah, so there's some hidden stuff in here. So yeah, FPU kind, FPU no, return fail. Which I guess is not surprising. This is something I should probably touch on later. Because this is another thing that could definitely go on for way too long. Yes, mock kernel for the i386 is exactly right. Yeah, because I found the source code ages ago. Let me find my thing. So if you go to SourceForge, look for NeoZ2. I can paste the link in here. I've been bad. I should have been pasting links in here. There we go. You can find all my exciting projects and stuff. Works. Yes, it works. How's the performance? Terrible. It is absolutely terrible. Yeah, the performance is a legit nightmare. I got my start with that XMOC thing. I managed to get it to fully build and boot when they were doing their weird little shuffle thing, and then it just evaporated, which was a shame. It was somewhat exciting, but you'll never get anyone really that excited for mock because the performance is just terrible. So yeah, if we go under Ancient Linux on Windows, no, it's not this one. It's Ancient BSD on Windows. Yeah, the performance of mock is just terrible. I really should update this, but I haven't. So it's 4BSD under Windows, version 4. And here we go. So we got a couple versions of mock. They're all very difficult to compile. Don't let anyone fool you. They are not easy. And the problem now is that a lot of this stuff is just drifted out because the researchers and people that get interested in it, they just delete everything, which just makes it all the more difficult. Let me see. I think this one just might be a hard drive. Yeah, and then add in floating point math, and it's not good. It's just really not that good. What I started with was what do you call it? The Mount Xenu thing, because it's Unix backwards. I'm too dumb. XINU. Yeah, that's it. Because their stupid thing was, we know Unix backwards and forwards. Ha ha ha. So I managed to beg someone that had this to get a copy of their floppy set. Is this just the documents? Yeah, I guess it's just the documents. But anyway, so on archive.org, I tried to get rid of my Google email address, and that's where I found very quickly you can't. You cannot change your email address on archive. So when I changed my email address, I lost my account, and then everything it uploaded disappeared, which really sucked. So I was able to do a recovery to get it back, but I had to rename my account, but at least I didn't lose everything I uploaded. So here's all my crap on archive. So I think under mock there should be, yeah, the stupid user thing, old Linux kernels, all of them. So this one you might find interesting. All the material of everything I can find. This has got a ton of stuff. I would use the torrents to download. But everything from herd to special GDB, the 147s, the all the version 3 stuff, the BSD subsystem. Yeah, so here's the Mount Xenu stuff. I was pretty sure I had the disk images in here. Oh, here we go. Yeah, it's a bunch of disk images. I never installed the X11. I never did, and the networking is just terrible. It really needs proper drivers, and unfortunately, that's just way out of my experience. So, like everything I could find, I put into this one archive. So, definitely get a copy of this if you're interested in mock. And then, of course, all the Darwin stuff to go with it. Oh yeah, and the John Teeter special. In case anyone's not familiar with John Teeter, yeah. OSF Unix, yeah, they use a mock kernel. It's the exact same one. It's in the 2.6. I compile Sarin on Xenix. Yeah. It probably can. I wanted to work more on the sound because I really wasn't happy about the sound. Really was not happy about that. Not sure if I had a pre-installed disk image. I think this might be just documents too. Yeah, unfortunately. Oh, wait, there it is. There's a hard drive image. 7-zip. Nope. This thing keeps jumping my mouse. There we go. So if I can right click, copy download link. Let's see if this one will play nice. Let's see. Get a QNUs. We've got a couple emulators. So it's, I don't have 7-zip on the command line. Downloads. 7-zip extract. Let's sound for complete other things, older things like Xenix. See, the problem with them is you really have to make the drivers and stuff. And that can get very complicated very quickly. Yeah, it's not going to be even remotely easy. MIDI sometimes works. Just because MIDI is very primitive. That's weird. I didn't see the directory. Yeah, so there we go. There's my disk image. Okay. Copy users, MIDI, download, mark. There we we should be able to do QMU, QMU. There we go. And just like that, there we go, Mach 386. So this is the Mount Zenith. The Linux source code is not going to help with getting device drivers running on Xenix. They don't share anything. Yeah, it's going to be completely different. And offhand, I don't know if there is any device driver examples for Xenix. I'm really not sure. Do I have anything on here? Yeah, so you see GCC 137. It all comes back to this old versions of GCC. Always does. So that's the Mount Zenith thing, and then this one should 7-zip extract. They got hiding on me. Yes, this one's just a VMDK as well. Alright, so this one was Mach 25 VMDK. Wait, did I copy the same one again? Ooh. Okay, so I guess this one, microkernel 35. Yeah, I think this is the one I built myself, I hope. Yeah, because this one's got source code. There we go. That's much better. So, Mach 5. Yeah, cool. So it's obj. Oh man, now I forget how to build it. Oh, I left the build shell. Because I knew I'd forget. Wow, what a pain in the ass. So let's see, let's just run build. Alright, so now we can compile mock under itself. At least it's self-hosting. Because I remember this is where I was trying to build my own like mock distribution of Unix, and I forgot. The problem is, again, they deleted so much of the source code that there's a bunch of weird things that differentiate in libc and whatnot. And yeah, all the source code is gone. So the kernel survived because of the CD-ROMs, the CSRG. So again, if you go back to my archive page, just look for CSRG, and then what you want is the DVDs. I paid Kirk a couple hundred for these things, and these are an absolute must-to-have, these historical archives. Extremely tiny. These are the ones you definitely want because they have all kinds of unbelievably interesting source code. And what I also had was the source code for mock. There we go. So it actually compiled in that moment. So VM Unix. Or it took us out of the directory, didn't it? So obj std. So I'm going to go ahead and just remove our original kernel. Whoops. Like how it doesn't complain. Yeah, even with the Linux source code, it's not going to help because it's not going to give you any hint on like interrupts, I/O ports, how to talk to memory. Like it's going to be completely different. Yeah, it's not going to capture anything. Yeah, unfortunately, yeah, this won't show like anything, I guess, verbose about it. But yeah, now we're running the kernel we just compiled. I wonder what the difference with make boot is. Oh wow, yeah, I forgot. There's so many hints on how to build this stuff, but yeah, there's just the full things aren't there. It was very frustrating, and then I thought people would be interested, but yeah, the world doesn't care. No one cares about 386 Mach. You know, it's just the way it is. There's no tops. I did compile top. Huh. But yeah, it's limited to RAM because of the ISA DMA thing. So you fundamentally have to change the way it allocates memory. It only can use a single processor. If you look through the Apple source code, they made huge changes to get SMP working. They were not trivial changes. But yeah, it's a virtual machine, so we can just kill it. I forget what version it is, but I'm not sure where I can publish this stuff either. But I guess I can show off one thing. Um, Probably a bad idea since I'm recording this, but DMXDJ. Let's extract that. Yeah, you're just not going to find the same thing, and that's part of the problem. It's just too difficult, and it's just too much. I know this won't work under the Go32, but I do believe it'll work on this one. So it's just 7-zip extract just here. That's fine. This should be version 2. So the port of GCC to DOS, there's two major versions. The first one uses that Go32 extender. Um, and they didn't like it because it's not free because you need Borland tools, TASM and Turbo C to compile the DOS extender. So version 2, that's where they changed the CWS DPMI thing. So it's a totally different extender. It's DPMI compliant. Go32 is not compliant with anything. Yeah, and then it basically just rehosted all the version 2 stuff. So, in case you ever wonder why it says DJ GPP V2, that's why. Where did I put my thing? There we go, DMX. So if I go into DJ2, go on to test. Let's see, so I don't want WinGW, I don't need this, don't need this. Make sure that this one sets from the current directory, it does. So this will give us a newer compiler. I don't know if I ever tried the older stuff on here. No, I didn't. That's just the one. I'm trying to remember. I think it was just because I rebuilt the tools to run under Win32, so I like matched build for build of the original stuff. And I did it in a weird way too, where this version of GCC for DJ GPP, I I compiled it under DOS and then did the same thing I usually do, which is capture the output, and then I reran the Win32 version of GCC over it. So that way it's not reconfigured, it's the same settings and whatnot. Keep it under, should be here, yeah, cross DJ GPP version 2. Yeah, so there's a version 1, version 2. But since this one talks DPMI, it's a lot more friendlier. And of course, there's the sound library for Allegro, so that's nice. And then, yeah, the version of Doom for this one has sound. So let me just modify my path. Nope. It's like I gotta modify everything. Yeah, don't run Doom. And then, where do we go from here? Guess we're back to test, huh? Okay, so let's make a directory for this. Guess you can be E. Oh my gosh, I should put an ad blocker on. Ah, it's so annoying. But this is just research. This is not serious. Yeah, and that's why GNU kernel does not exist today. Yeah, exactly. It's the mock kernel is that siren song of perfect design and it's gonna be great. Everyone agrees. There's one thing I've definitely learned. When everyone agrees, it means it's a disaster. You don't want it. You do not want it. Okay. Now I'm not sure how much crap I have to copy around. So this was DMX, DJ, DD, API. Need the music file. Oh, I guess under MIDI then. Why is it? Apparently auto-completes, huh? I should see if I got DPMI. Nope, I don't. Of course not. Oh, I do there. Okay. I need this in MIDI. So let's try AdLib. Couldn't find Gen MIDI OPL. Gen MIDI. Don't worry, this is going somewhere. Trust me. Copy example, Gen MIDI, PD MIDI. Either super loud or really talking. I don't think it's getting the audio. Oh, that's not right. I think it crashed. Let's be in more window. Hmm. So let's go properties, and I guess not capture audio. Okay, add, I want to get application audio capture, so I want VMware audio. Window, I do not want Internet Explorer, I want VMware. Okay. And then VMware Audio. Let's see, it's at maximum. I don't think that's right. So let's see. I don't know if anyone can hear it. Well, that's disappointing. Because the graph here doesn't like move at all. Let's try this other DOS box. It's not going to capture any audio, is it? Come on. That's the sequence of DJ GPP82. See if this one goes without crashing. So I should be able to go DMX, DD, MIDI, Weymouth, action, form music. Because there's jumping on the bar. I know, yeah. I know. Yeah, you should be able to hear it now, right? Let me know if you can hear it. I might stop. Oh. Oh, and then the program crashed. Fantastic. That was, I don't know how to capture the audio properly. That's, that's annoying. That's really annoying, because I remember this thing working. At least better than this, but... Anyways, I guess the hidden surprise about this is that, this is DMX. Yeah, DMX is the audio engine for Doom. And I'd ported just enough of it to play MIDI and stuff under GCC. Yeah, it's so annoying though. Yeah, it's just got the one music file, but... Yeah, look at that, it crashes. Oh, game runs too fast. The CPU count. Yeah, it's a CPU count. Because it definitely suffers from timing problems. But, the source code is like almost incomprehensible. Yeah, and I also have problems with the ISR. Like I said, ad lib, action for music. That's so weird because it shows pulsing on the desktop audio. And I unclick desktop, and then it crashed. Oh yeah, I forgot again. Max CPU cycles. This should not be at max. See if I can just catch the CPU to not freak out 100%. Yeah, it's for DOS systems, but I wonder if it's because I'm inside the VMware. DOS box is so problematic. But yeah, they ported this to at least compile with GCC. Because obviously, coming from Wacom to GCC, they have nothing in common. So it's like in that same idea of like trying to take a Linux driver and porting it to oh yeah, taking a Linux driver and porting it to Xenix. You'll run into the exact same stuff. So this is a Wacom DOS audio thing I ported to GCC. I know it runs on real hardware. I know it runs under most emulation. It just really doesn't like DOSBox for some reason. I'm not sure what the heck that is, but yeah. And then timing problems, weird things, and Sound Blaster 2, Pentium. Yep, that's just it. The faster the CPU gets, the worse it's going to perform. It is an absolute nightmare. And then, like what caused the problem? Don't know. Don't know. And then how to detect the problem? Yeah. Oh. Because sound is a real-time hardware problem. Yeah, it keeps crashing. I'm not sure why. But I do think on here, I might have version 4. Maybe that plays better. Yeah, see I built a version 4. This is what I was using for doing Quake 2 for MS-DOS. Yeah, maybe version 4 will be better. Let's extract here. Oh, yeah, I forgot I set the path to hard-coded. Such an amateur mistake. But yeah, we got version 4. So I go back to version 2, and it was test, DMX, test, DMX, DD, API. Alright. And let's see if it does anything. So it was DMX, DD, MIDI, Play moves. I don't think it matters, but we'll just go ahead for ad lib. There's only one song, action 4. And throttle the CPU down. Yeah, quick food for that. Absolutely a 10. Yeah, there goes it hung. But then again, I was altering the system volume. So maybe it's just being under emulation. And then, yeah, this is using the MPU 401. This seems to be working. So I can fade out, fade in, I can stop, resume. Change the volume. Oh, because Quake 3 Arena requires 3D hardware. That's part of the reason why. And it really needs OpenGL. So there's no real OpenGL for DOS. That's kind of the brick wall we hit. And it just really wasn't worth it. But I was going to say, yeah, this is the page for the port. Yeah, Frank maintains it because I just did the initial work and then I lose interest. But he was able to get 3D effects in there because someone had the 3D effects port and they were giving the source. But unfortunately, the Quake 2 video and the Quake 3 is just too different. It's just too different. Which is a shame, but you know, what can you do? So yeah, as you can see, yeah, it's definitely involved. Oh wow, I should update that. Well, at least it's got my blog in there. That's fine. Yeah, porting this to DOS, it wasn't so bad, the initial one. It was just the source code had rotted a lot. It needed a bunch of help. Yeah, and Misa's just not up to the task. And even if it could, it would be insanely slow. Because that was the one thing we'd always thought is that Windows suffers from so much overhead that running Quake 2 under DOS should be so much more faster. Because, you know, that was a smart prevailing thing. Is that Windows gets in the way and it's just too much hassle. And if you could just run Quake directly on the hardware, it'd be so much better. And then that's when you find out that, no. No, it is not. The Quake on DOS is substantially slower than Quake on Windows. It was very disappointing. But yeah, I guess it just comes down to the fact that you know Windows is a lot better at handling I/O than DOS is. Yeah, and then, yeah, I've seen Hexen support for OS2. Yeah, I'm not surprised, but OS2 has no real hardware support for 3D or anything because again, just there's no market there. You know, it's just a sad fact of the state of the thing. You know, nothing else really has solid 3D because I mean, it's one of those things. Look at the market share. You know, if you write a game on Steam, if you're supporting Linux and Mac users, you are wasting your time. You know, the Windows market is just so huge. It's just not worth your effort. And even though Steam's managed to pull off their deck, they've finally got a customer base over 1 million, but there's a lot more Windows PCs. A lot more. And of course, you know, all those Steam Decks, you know, they have that Windows compatibility thing, and that goes a long way as well. But yeah, this port was kind of fun. I almost thought about retouching it just because of this is all GCC and it's all reliant on GCC's dynamic link library support, which is surprisingly robust. Because I never realized it until we started doing the port, is that Quake 2 loads and unloads itself constantly. It's like its memory model's kind of messed up. I never got Odin to work. I've heard, but yeah, I've never gotten it to work. I mostly just use OS2 version 2. Because I kind of don't care about Windows and kind of don't care about DOS. It's all IBM's fault, exactly. It's all IBM's fault. They totally screwed up. In every conceivable way, they messed the whole thing up. Yeah, I mean, look, I want to run OS2. I want to run OS2. I don't care about DOS and Windows. Yeah, I'm not interested. Oh yeah, here's another cool thing. The DOSBox thing. I really like this. It's another reason why I should probably work on more audio. But yeah, this is the Serial port to the Wacom 7 and Farlap 4. So this is neat where you can load a disk image, boot up from there, boot DOS, load Stacker. And it's so fast too. Do I have a game on here? Yeah, the Jungle Ride. This is a good test to see just how fast it is. This is so fast. Nothing like an emulator emulating an emulator, and one of them's JavaScript. So that's the 386 version, and then this is the 286 version. Yeah, this is the Farlap 286. And this was just kind of, you know, I've always wanted to see how badly a game performed using Farlap 286. And the answer is, oh, it's bad. The DOS version of this runs out of memory all the time, so at least it fixes that, but yeah, look at the speed difference. Yeah, I'm almost thinking of going to Linux. As much, you know, like I said, I've been using it for a long time. I've had on and off times using it. So it won't be the first time. It's just disappointing, that's all. But yeah, look at the difference in 286 performance. Like, wow. 386 memory move instructions are just so much more faster, so much more robust. And this is basically the performance left on the table from, you know, OS2 being mostly 16-bit. Yes, this version does have VGA support, but the for some reason I just couldn't get it to work with Wacom. I'm not sure why. I just didn't spend enough time trying to debug it, because the other thing too is I kind of wanted the 4-color version because it would run on Presentation Manager. Because my ultimate goal was to get a you know, a game up and running for OS2. Yeah, but the difference is you can run it on the desktop. That's all. I have like a Ready to Rock and Roll version somewhere. Yeah, it's VMware, so that's not going to work. Yeah, installed on 86 box. Ah, I've already downloaded it. Nice. So if I can just cut it, do I have 80? Yeah, I have 86 box on here already. Ah, as a matter of fact, I already have like the thing. Wonder if I can just go copy here, paste the shortcuts, properties, 86 box, start in here. Apply. And I should be able to call you MSOS2, right? Give it some funky name like that. Yeah, I'm kind of considering it for my main OS2. Just that stupid thing about being able to look through your history is such a terrible idea. You know, because there's a lot of people that have access to systems that they don't have at home. You know, a lot of people work remotely, no matter what they say or want. There's a lot of people that do. And they have access to military systems, healthcare systems, legal systems, you know, banking, everything. And the fact that there would be a Microsoft thing sitting here and screenshotting it all. And no matter what they're going to do for security or whatever, if it's saved on the screenshot, someone's going to figure out how to do it. Someone's going to OCR that crap. It's just catastrophic. But yeah, this is why I wanted the CGA one, because I wanted to see this. Even though it's just speaker, I couldn't figure out the tunes on this. The timing, the frequency length, I just can't figure out the math. But just because this versions of OS2, they only do 16 colors max. So you can get the 4 CGA colors and not crash the palette. I know at some time I'm gonna have to profile this Therian because its performance is just terrible. I mean, it runs on my real PS2, but it is so slow. And of course, this being 86 box, it's not going to run like at full speed. Yeah, Jungle Ride. Yeah, at least I keep my save games all over the place. Here we go. Whee! It's so slow. I have no idea if the speaker beeps are coming through. Maybe if you're lucky, they're not. I guess I really got to get a headset to listen to this stuff. Yeah, wash out CDE colors. Yeah. I mean, that's just the thing. You're talking late 80s, early 90s. They really had no idea what they were doing. I mean, it kind of shows for all this stuff. If you get, I mean, there's no wallpaper. It's just IBM bland everything. Yep, 1989. You know, in case you're always wondering, like, you know, where we were in the 80s. Like, yeah, land of suck. But at least this one can run DOS. What a killer feature for the time too. DOS in a window. we go full screen? Yeah, there we go. And then you run the real version. There you go. But OS2 being OS2, it doesn't have the timing priority right. Oh, if you can't see blues or purples, yeah, you're gonna miss out on a ton of stuff. Like even this. If this is all blues and purples. Oh man, what a nightmare. Enter to quit. And exit. Oh, you hear the beeping. Yeah, sorry about that, but at the time though I thought this was so cool just because, you know, being able to play like real games on OS2. No emulation, something native. Yeah, this would have been great. Yeah, and that's just the thing, they all kind of sucked. I can't believe I played this all the way through in one. On OS2, on emulation. Ah, oh, this was such a nightmare to play. That stupid maze. Do I have it in here? No, I don't. Ah, there's a maze in this game that is just freaking... Took me like an hour, if not longer, to get through because these controls are just too sensitive. And also because if I tried doing an input queue, it just went to hell. So it literally only reads one key at a time on the keyboard. So it loses keys all the time. So if you got to do something quickly, yeah, it's not happening. I think it's over this way. I don't think tell the guy to run. You can't run. No kidding. And then just the way the emulator for this engine runs this menu is so slow. Speed, fastest, please. Yeah, it's going as fast as it can. I think it's up through here. Yeah, this thing. Ah, no, 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 don't die. Let me just save it real quick. Not sure why I'd save it, but I've already beaten this thing. I don't think I've ever played it again, really, just other than testing to prove it works. Yeah, so look at this screen. If you can barely see the pink over the purple. Oh. And if you just touch this thing, boom, that's it. You're dead. That's it. Game over. Which is always funny because people always act like they're so nostalgic for 80s games, but they were so unforgiving. One wrong move, boom, you're dead. Every little thing. That's it, you're dead, trust me, and it just keeps going on and on. Did you get the part where you're dead? Because you're dead. Way to go, Wingnut. You're dead in case you missed that part. Oh yeah, because I didn't do the icons or anything. I'm surprised this thing works as well as it does. A splotch of hair moving around in a bunch of pinkish mud. Exactly. It's terrible. I mean, I guess I could cheat because, of course, you know, I've got source code to the engine thing, so I could change the colors to be more wild. But I did like the fact this feels more like an authentic CGA game running in a window. on OS2. So it'd be like, wow, all 32-bit. Close. Versus, Flight Simulator 4. Running happily in a window. But, this is what they use for their demos to show off OS2. So this actually works properly. So you can see purple sky, blue water, purple panels. This must suck because you probably can't see anything. I guess maybe the yellow horizon. Yeah, this is definitely one of those things where like the emulation's too good because this is what it was like in the old days. It was just a slideshow. I'm not sure what I'm trying to emulate. 486SX, let's go all the way. I guess DX4? Well, I don't want the math coprocessor though. But they're all DXs, aren't they? Yeah, I think they're all. Wait, the Pentium Overdrive. Again, the math coprocessor. There's an SX2. How fast do you go? 66. Not fast enough. Cyrix goes to 133. So dynamic and soft float. Yes. Because if the math coprocessor states wrong, OS2 freaks out. I used to love Project X for the Amiga, but I can barely get past the first level. Actually, that was one program I thought about trying to port, was UAE to OS2. Let's see if this is any better. For our fake Pentium. Or a Cyrix 586 thing. I guess it's better. There we go, finally. It's still a slideshow. That was always the frustrating thing with flight simulators. You basically needed a computer that didn't exist. And then on anything modern, it's just going to be unplayable because it's too fast. Like, there is no sweet spot for these things. You're definitely not getting any smooth 30 frames a second, or 60 frames, or 120, or... Yeah, it's just still a slideshow. And I wonder if that's like hard-coded timing in the emulator. I don't know. Or I should say the simulator, not the emulator. But this should track a lot faster now, I guess. Yeah, a lot more faster. Oh yeah, because I use VMware to play this. Because yeah, this really sucked under... this really sucked under 86 bucks. And then I could magnify the screen if I remember, because yeah, good luck seeing this. This was definitely walk, save, walk, save. Yeah, and then that's the other fun thing. In some of the walk animations, the guy's legs just disappear. I didn't know there was a DOS version. Huh. See if I can blow this up. Thank you, Windows. There we go. So, as you can see from here, he's got no legs. I can't believe I made it through this maze. The best part is you have to do it twice. Once in and once out. I think I literally spent an hour doing this stupid maze. So frustrating. It really is. Like, people really think this is fun? Like, no. But I never really played the CR games back in the day because I had that Commodore 64, and then when I got my PC, it was like late 90, early 91. So I remember Windows 3.1 hadn't come out yet. Windows 3.0 was all the rage. And it still supported CGA because that's what I had. A 286 with CGA I built out of junk parts I got, you know, doing trades and stuff. So going from a Commodore 64 to CGA, that sucked for games. 16 colors, granted you can't change them, but 16 colors to 4, yuck. And I honestly just didn't have time because I used to work back then. Yeah, because I was like 14. So yeah, no one gave me the PC and all that. I had to go work for it. Wow, long time ago. Well, there's a nice bug. I guess that's why this is beta. I can't remember what I have on here. Yeah, from one virtual machine to another, I guess. Oh, no compilers, that's why. No compilers. This thing's kind of useless. I'll just shut it down. Oh my goodness, I just noticed I've been doing this for 4.5 hours now. Ah. So let me just see if I can recap anything useful from this. Getting GCC from here, gas from GitHub. Of course, remember to explain carriage return line feed nonsense. Bison I had from there, but I had to modify the data directory. And GCCs had to be modified to pick up the bison, and of course where the gas was. And the whole nonsense about being able to link natively because the Xenix gas outputs OMF, which old link understands, which I'm sure they left in there by mistake. Then the Doom thing. Oh, I should almost try. What version of GCC are you? You are version 4. I bet I have a Doom on here. I do. It's probably V2, right? That makes sense. But you don't have a make. Of course not. DJP V2 bin make. It's a problem. Sometimes I forget where I leave all my stuff. There we go. Okay, that sounds promising. So this would be E, right? Doom test. But the difference is now this is V2, and it should have the Allegro engine, I think. So if I run Doom, no DPMI. Ah, come on. CWS DPMI. There we go. That's better. Oh, you gotta go to dinner. Okay, no problem. I'll probably be heading out soon too. That's right. The Z-Doom thing. That's right. That's where I had the thing annotate all the images with words. So I just go do all. And this will fire up image magic and then put names on all the flat textures. And then patches, yeah. Oh, right, because I don't have the thing in the path. This will reassemble the WAD. And then this was DJ V2 test Doom test. And then we go back into here. And we get rid of the demo. And now I should just be able to run Doom. There we go. Oh yeah, so you can see that's my blog, that's my PC. But this one doesn't have the crazy math or anything. So yeah, reality doesn't change. But we can fix that. We can fix that. So, XDJP test Doom OD. So we want ST stuff. So we can just copy these, right? That's Y. So ST stuff, our main, and tables, and then the fixed math. Then in the make file, we should make sure we're not using that. We do ASM. No, we don't want assembly. Oh, and then I definitely need not soft float. 83, 87. Okay, so and make, no, and make clean pile. Undefined reference to draw span. Oh, good grief. Where are you? Why are you not getting defined? R draw span. If not defined DJ GPP. Ah, okay, because it's doing the assembly thing. Alright, fine. I'm not sure on the preprocessor, but basically and def, ASM. Which I know that's not going to work. Well, it doesn't matter, it didn't work. Alright. So make sure to come back here. Right, here we go. We got my pi fixes and all the floating point calculations for the table. Yeah, no more assembly, no cheating. Oh, I hate that music. Oh, the volume doesn't work under Allegro. Wow, that's not good. Oh man, that music is just annoying. Mixer. There, we can diminish it. I do have a Pentium board, but I don't have VGA capture, so I'd have to hold a camera up to it. But it might be interesting just to see how bad this is. It's so weird, I guess, in a way, to play when you don't have the textures, but you kind of remember. But at the same time, I never really tried to do this before, and I gotta say, it plays a lot better than I thought. Yeah, I need to replace all this rest of the stuff. Get custom levels or something somehow. I mean, God only knows where you go to find people that can make Doom levels. I almost like the idea of like an office layout of Doom. Whoa. Whoa. Keyboard stopped working, that's good. Or maybe it's just a DOS-box inside of VMware. It could be one of those things you hold the keys down too long. I like how it looks like the walls don't join until you get up to them. See if you can walk in a straight line. See, that's the other thing. You can't walk in a straight line when pi is no longer pi. It's almost very disorientating. I guess that was really good. I'd look at all the textures and stuff, get the basic dimensions, and see how much size you could cut out of the Doom WAD file. I mean, then again, I guess maybe if you're a new player, this is just unimpressive or whatever. But if you recognize it, you recognize it. And then instant death. Yeah. Oh my goodness, it's 11 o'clock at night here. I think it's a good place to call it. So, how long have we been going? We've been going for 4 hours 45 minutes. That's pretty long. So, hopefully, it was somewhat enjoyable to someone. I guess, yeah, I guess showing off, messing with compilers and stuff, where to put stuff, how to interface stuff, moving things around. We built some Linux. We didn't build DOS, thank goodness. Kind of sick and tired of building DOS. Got to sneak in some OS2. We did build a BSD kernel, but I gotta remember how to get them up to boot. And I guess I gotta mess with Mach, because now I'm thinking from memory, maybe I could build the vast majority of it on my PC under Windows, and then I uploaded the object files to link. Oh, you know what? That's part of it. The Mach kernel doesn't link properly on the Windows linker. There's something different about LD for Mach systems, and I have no idea what it is because it is not documented anywhere. And yeah, nobody saved it. They clearly made changes to the bin utils for GNU, and they did not publish it, and all that stuff is gone. I completely forgot that was another like catastrophic problem. Yeah, you basically have to make your own format or lean heavily on the Linux stuff. Yeah. Oh, what a